I'll go ahead and get that going. My bad. M. Oh, M, I have a song for you. Should we do a new one, guys, or should we do one of the previous ones? M, I heard some music here and I thought of you. I was like, this singing voice reminds me so much of M. And I just shoveled the whole driveway. Dang. We haven't gotten a single piece of snow this year. Christmas is coming. Dear God, come on. Give us some snow. All right, Em, hang on. I got to queue up this song, and then I'll try and pass while this song is playing. Em, do you want a Christmas theme song? Do you want? We played. My hands are literally shaking. Oh. Let me see if I can find the. Give me a moment. Wait, shh. Here we go. Hang on. I'll be feeling this tomorrow. For sure. Okay, this one's for M. I've got to use the restroom. So I'll subject you all to this. And I'll be right back. Oh, wait. Is it unmuted? It is unmuted. Okay. Is it? Hang on. Oh, no, it's not. Unmute. Let's go back. Excellent music. I don't know, something about that just reminded me of you, Em. I don't know. Really makes you think. It's a great song. Very it's very moving. Really gets you in the heartstrings. Okay. So now what we're doing is we're magically taking a vector 2, we're turning it into an integer, and then we're spitting it back out. We're able to turn that integer back into a vector 2. As if by magic. And now with one byte, we can now create many degrees of analog input. Yay, us. So let's put this over here. So this looks like this then. There's the magic. That's the secret sauce right there. Okay. I don't know how to feel right now. I love you, Em. It's not. I just love I love the it's just great juxtaposition, really. And that's what we're really looking at with that. Okay. So now we can get rid of this. And we go like that. And we don't. So we have the direction int. So this all goes in here. We're putting it into the byte down here. And then we have to reconstruct everything. So then we go here and we magically turn it back into a direction here. Dir is an index. It's an index of a vector 2. Okay, so now theoretically, we should be able to start moving around again. I think everything's okay for us to start moving around again. Let's see. Oh, Christ! Christ on a cracker! Okay. We know what's going on here. We know what's going on here. And that is if we're 128, so we do need a one check here. If the input is 128, if input equals 128, we are returning vectors to 0. Okay. So that's actually us moving like that was a sign that it's working. Christ on a cracker! Still doing it. Okay. So let's print out our direction. Ant or input. Oh, input is oh. Oh. Inputs everything. Oh, and we're grabbing the wrong thing now. Okay, so this needs to be this is I'm going to put this here. And this is a U8. And then this is going to be direction der int. Der int. Oh, der int. Oh, der int. Oh. Der int. So we go der int. Okay, like that. Der int. Son of a bitch. We're still just going off into you're the man now, dog. What number were we getting? 0. Bruh. I'm sorry, brah, but it's not 0. Dar int. Encode U8 direction in int. So how do we If it's a 64, okay, bros. It's a 64-bit number. This is a problem with the encoding. This is a reason. This is what sucks about Godot not having a. So yeah, we're trying to encode 128 into an 8-bit, but it's a 64-bit value. The float is 64. So can we take? How do we take a Godot integer and turn it into smaller, fewer bytes? Cast it to a byte array, right? Is that how we do it? I don't know. Let's see. Cast it to a byte array! Be rid of it! Cast it to a byte array. Cast it into the fires of byte array. That's what I'm doing right now, though. So we're using encode U8, but our number is a 64-bit. So encodes an 8-bit unsigned integer at the index of byte offset bytes. The array must have at least 1 byte of space starting at the offset. Are you eating tacos? Are you pooping on the toilet now? Bruh. Bruh. I don't know, bruh. So what? Let's decode this sumbitch right here, right now. Oh yeah, we'll think you're real smart. We'll decode you, sumbitch. See what number we get when we decode it. So I'm going to say print encode decode. So when we encoded it, it looked like der int. Der int! Ah, yes, der int. Yes. Oh, wait. We're in the wrong thing. We want to get it when we're encoding. So we want to encode der int. And then we're going to decode it. And we don't have an offset. It's ring index. Ring index. 10-4, Big Daddy. All right, let's see what we end up with here. So we're decoding properly here. So something's wrong with our friend down here. Ah, decoder int. 9. 9 times. He's been absent 9 times. Ferris hasn't been absent 9 times. Der interessante. Are we not? Did I poop my pants? Do 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 poopy pants. I pooped pants. Der int. It's too Bob. Little feedback there. Ah. I think if two Bob and I worked in the same, if we were cubicle neighbors, I'd be getting an HR visit. I'd be like, hey, you got to come in. There's we've been getting some complaints. Bro, what is going on right now? I mean, this isn't even printing. Der last. Set input. Der last. Last input equals new input. Der last. Ah. This is part of the problem here, folks. This is part of the problem. This should be direction input. Direction in int. Der last. Go like this. Okay. Der last. Whoa. I literally worked myself into the ground until I had my own office in a corporate for much similar reasons. Dude, I thought I'm so weird and when I'm cooking, I get to be very loud and vocal and I'm just talking to myself. I thought for sure they'd throw me in an office. But instead no. No, they just kept me out there. I didn't understand it. It didn't even happen until they knew I was ready to leave. And then all of a sudden it's like, hey, you get your own place. I was like, too late. I'm sorry. I'm chicken. Oh! My God, look at how smooth it is. Look at that. But why are not it printing? I have a print statement here. Oh, this is a different spot. Der int. Let's put der int here. And go like this. Look at how fucking smooth that is, boys. Oh my gosh. We're going to have smooth ass movement. Look at that. So that little number there becomes magical analog direction. So the question is, I think this is going to be a disaster hooking this into a server client. Let's try it. Yes, I'll show you the math here in a second. But I think we're going to see that this doesn't work on the client side very well. But we'll see. Oh, no, it's not too bad. Look at that. Whoa. But we are getting some rollbacks in that. I think that's because we have an off by 1 with the input ring that we're sending. So I'm pretty sure there's an off by 1 that we have to fix. I did a lot of refactoring last night for that. So we're going to be able to fix that. This is beautiful, boys. Boys and girls. Stay off math. Don't do math. All right, let me explain it to you. So let me explain the math here. I'll do the best I can. So we have, I'm going to repeat this down here so you can see it. Okay, so this is how we encode it, okay? So we have a direction value, and what we're doing in Godot land is we're saying input get vector, okay? So we're getting vector coordinates for our configured inputs for P left, P right, P up, and P down, okay? So we can P in all the directions, all right? So we P in all the directions, and the P left, up, and down, all that stuff is from our analog, left analog stick, okay? So this converts those Godot, input configs that we have here into a vect2, okay? So now we have a vector2 of our analog stick, okay? Pretty straightforward. So then we run that through atan2, and we multiply, or we add pi to it, okay? And that gets us a float value. Oh, my camera's covering the code. My bad. Let me get it out of the way. Oh shit. There we go. Okay, so we atan2, which is, let's look it up again so we know what we're doing. So this has got to be what they're doing in like Halo and stuff. I was so confused. I'm going to be honest, guys. When I would watch the talks and they would be like, "Oh, we're sending the input values over," my brain was like, "How? How are you doing the analog part?" But this is all thanks to Medusa, the missing link here. So atan2 returns the arctangent of the xy in radians, the yx in radians. Okay. So that gives us the arctangent. So then we say, so we atan2 the vec2 that we're getting from our analog inputs, and we add pi to it, okay? And then what we do is we turn it into an integer by, we round the float value that we get from arctangent divided by tau, I don't know how to say that, tau, times 256, okay? So that gets us, it turns it into a value of 0 to 256, okay? And that's what we encode in our byte stream, is that number. Then on the other ends, when we get that byte, when we get that integer, tau is right, okay. So then when we come back on the other side, because my math is wrong somehow, if we're not pressing anything on the analog stick or we're close to 0 at center, if the input is 0, we're returning vec2 0, because for some reason this math isn't quite, it's not quite producing the exact right result. But anyway, so then we take and we return a vector2, we take the input integer, the direction into, this should really be direction. Dir value. Dir value. Just to make this easy for us to understand. value. Okay. So we take the sine and the cosine of, we're just kind of doing the inverse of that other math. So we say the integer times tau divided by 256. And then for some reason I have to multiply it by -1 because it's inverted when I unpack it. And then we do cosine and the same thing again. And that gets us almost exactly the number we started with, which is wild. Because we're dealing with such a arctan is what makes it negative. Okay, versus tan. So do I do tan instead? Tan 2? Maybe. Let's try it. The fewer math operations that we have to do, the better. We're broken somewhere. Oh. There's no tan 2. Tan H? Hyperbolic arc? Atan. But then do we not need pi for that? Tan 2 is for x and y. Sin. A sin H. Co. I don't know. I don't know what the operation would be otherwise. Arctan is not the opposite. -1. So I could make the value in the that I give it inverted. Anyways, regardless of all that, we end up with something approximating what we wanted. Could just do times pi, but we're adding pi. It's the inverse. The negative is all I'm saying. Not the negative is all I'm saying. Oh, I see. Yeah, this stuff is all out of my brain powers. I'm gonna have to relearn all this stuff when I start doing these things for in math class with my daughter. But yeah, we end up with so we can see what the server ticks look like on the client side. So we're not getting the same exact smoothest looking movement for the server ticks, but it's still pretty damn good. Right? But I am snapping player rotation. But we could smooth player rotation. But there is a problem of determining what direction we should go in when we do that. So I think we should only smooth it if we know it's it's not larger than 180. Our change in rotation, or the number of degrees. So it's not a number larger than pi, because otherwise we can't determine if we're going left or right when we rotate. Or we're not going clockwise or counterclockwise when we rotate. So if it's larger than that, we snap it. If it's not, we can smooth it. But I think that even that will maybe look wrong. So we're going to have to experiment with that so that the sim looks clean. But Yeah, it's surprisingly good. So we still have that. So now, why did we do all this? We did all this so we could start to do the camera stuff. So we're still sending the exact same number of bytes, and now we have this super smooth input. Let's go ahead and commit what we've done. So yeah, we got rid of all this wild stuff. It really did I was so confused. I was like, how are they sending analog and getting such like smooth results for simulating? I really was just confused about that. Because the idea of taking an integer or taking a vector and turning it into an int and then back again just hadn't even occurred to me. So I was thinking of it as on and off, bits. And this actually frees up. This does more than what we were thinking. This frees up slow, medium, and fast we can get rid of. So if we want to still keep it at 2 bytes, we can now add more than, we can now add, Jesus Christ. Okay, so I think we can do almost all the buttons. Let's see. The front ones are, so there's 4 for our front, and then our shoulder buttons are 4. So now we can get rid of slow, medium, and fast because we can use the analog value that we have to reconstruct that for our direction input. So we don't need to do this anymore. So now we can mask all of our buttons. We can mask the 4 facing buttons and the 4 shoulder buttons into these values here. So now we have a total of, with these 2 bytes, a total of 8 input buttons and our directional pad. Use this info once a decade, tops. Even with the on-off bits, each new bits adds 2 times degrees of variable representation. When I saw 256 degrees, I meant literally degrees of variance, not even. So we kind of talked. You saying that triggered in me, and the result is a much cleaner execution. It's easier to follow what the hell's going on. It becomes only like 2 lines of code. So yeah. So now we have a little bit more work cut out for ourselves, but we're technically working on 2 things now because of all this. We are working on camera controls and inputs. Camera, and input controls. I don't know. Controller. I don't know what to call it in the stream, but this is the stuff, you watch these talks and they're just presuming that you're going to understand. Oh yeah, I would just do this to turn the analog input into a small packet of information. And it's like, okay, I just figured that out on my own, I guess. And it's like, oh, here we go. So yeah, I agree. I'm with you. There's probably a better way of doing this. Again, the fewer math operations, especially if we stick to multiplication and addition, the more often we can hit multiplication and addition, the faster all this shit's going to go. So if we change the order of operations and stuff like that in order to get that as a result, it's just better in in the computer instruction land. So I wonder if you can skip the 256 multi. Well, that's how I get it into. So this turns it into a value between 0 and 1 here. And then I multiply that by 256 to get it into the range. Yeah. So that's how we get it into to the range of otherwise it's float. Yeah, exactly. And a float's a much larger number to store. So now we should do the camera as well. So we have dir and dir last. And now we're going to have cam and cam last. And I guess it would be cam dir. But we'll just call it cam and cam last. And slow and medium, we could also work on getting this to be... See, we do this here. We do... if we do this after... We don't have to translate this. So we go like... I think I can fix this right now, actually. And then we have to change it on the other end when we unpack it. So we're going to put it over here. We always want to work on the number we calculate it to. Direction value. Direction value. Rotated. So this is all going to be weird, though. Cam last. Impressive. Ghost. Oh my god. Wow. That took some thinking there. That's a thinking man's joke. Jesus Christ. Oh my god. It's 2 Bob with a 7 stream streak. Make it unsigned? Well, we are encoding an unsigned value. Do you mean for the ATAN thing? Removing math ops from a single line of code. Yeah, the reason why I'm hesitant to think that in this case is because it's a scripted language. And so it tends to end up being more literal when it turns into instructions. Cricket actually working a lot today. That's because you're not talking, Doddle. Zing! I'm kidding. So we're gonna say dir last first. We're gonna do it up here, and then we're gonna say instead of direction value, we're gonna say dir last. So we're gonna do the math on dir last here, and then we don't need any of this anymore. Look at that. It's at work, Dustin. Do you just put me on? Do you put streams on audio only, Dustin, when you're working? So this concept of fast and medium and slow needs to be reintroduced into um it needs to be put into the player controller when we execute the input. Distance 2. So we say dir. So this will become dir and so this is paste this, and that means we can get, so this is dir index. So speed should be calculated after, so it's going to go down here like this. And we go get rid of these guys. So look at this. We're just getting rid of code. This is nice. I was listening to somebody explain how LLMs, the idea of removing is like difficult for them. So that because they're trained on output, they want to produce output. And so when you want to say, hey, I'm going to give you this input, make it smaller, have it do the same thing but make it smaller, it struggles with that. I don't know if that's true. Somebody could tell me who uses that stuff. But it trends towards inflating code and not thinking about having smaller code. And part of the reason is it's trained on just GitHub and everything. So you end up with a lot of verbosity where maybe it wasn't necessary in the first place. Because it uses stacked context. Yeah. It's interesting. It's an energy problem. Ultimately, the entire thing is an energy problem where it's like, well, you could then you could have a thing that trains the other thing that tells the other thing to act like a person who knows that it should be this, and then that thing does this other thing that tells it to do this thing, and then this thing tells it, and it's like, okay, so maybe we should have stuck with nuclear power, right, guys? It's what's also really interesting is it's wildly inefficient compared to the. This is where we need to stop telling ourselves the existential crisis thing that people are kind of like, it's hitting younger people the most, I think, right now with AI. It is incredibly inefficient. Think of all the power it needs to produce the output that it is versus how little energy the human body takes to power its mind. And like, if you compare the two, our brains are far more efficient than artificial intelligence and language models and everything. And from a synaptical vectorized database, from looking at it from a synapse perspective, we're still, even from that, we're more efficient. So even from a power output perspective, but also from the number of connections that our brain has to make to reach an output, it's far less. I do wonder if the real breakthrough, this is a terrifying thought. I wonder if the real breakthrough in all this would be biological. Oh my God, too, Bob. That's great. I was thinking, too, Bob says, I was thinking about buying an NVIDIA RTX Pro 6000 Blackwell today. It's also it's also cheaper probably to have a child. Oh God. Oh my God. That's great. Slime mold. The term is organic computation. My fear is we would figure out how to containerize brains, human brains, and actually um uh but who knows? Boolean. Dude, do you even sleep? Not when there's work to do. Okay, so now we don't have our fixed degrees of speed. Now it's truly analog. Maybe. This might not work. No, it does. It's acting like it's on or off right now, though. So we have to rechange our player code. This is on the player controller. So that means that again, everything is just getting cleaner in our packing of our bytes. So now slow, medium, fast, these are now can become other things. We're referring to things as action A, B, and so on. So I need generic names for this because what the buttons are doing, depending on the state of the player, could change. So what do we call do we just say facing buttons? Do I just call every button action A, B, C, D, E, F, G, H, I, J? Do we do that? Like, how can I refer to this in a byte way? Because I can't name it, oh, it's button X or whatever, because the reason why I want to avoid doing that is because people can remap their controller inputs, but I want the byte to remain the same for whatever the input ends up being. Yeah, it does. So I think some sort of named thing might be the way to go. By action. The problem, though, is that, for instance, the X button could become, in a certain context, it's mining. And in another context, it's selecting something from the ground, picking something up from the ground. So we can't call it by a gameplay hook or a game mechanic sort of thing. It has to be more generic than that. You can always name them based on your favorite controller. Are you streaming 2 times a day now? No. Mondays, Wednesdays, and Thursdays are nights. If I can stream, that's when I'll be streaming. And then Fridays are kind of up in the air. Same with weekends. So my full day streams are a little in the air. Dude will utterly be able to encode brains. It's terrifying. Makes me scared. Yeah, I don't like the idea that we might farm. I mean, because at that point, what for? We're taking things that could have been conscious so that conscious things can enjoy their life more. Like it's weird to think about it from that perspective. It's a huge like ethical. If it was man-made biological thing that didn't involve, I don't know. It calls into question a lot of things. Context button. So like context A, context B. Do we say shoulder action A B? They're creating artificial brains now that are organic. Ah. I think we're gonna do something where we go down a route and then we find out something about consciousness and we realized we did something horrible. Um context shoulder button, context shoulder, context button. So anyways, here's Wonderwall. What's that DJ that did the shout out to the family of the guy that died? Oh god, that was awful. Okay, let's look at the player controller here. And when we process inputs here, and we have dir that comes in, and then we do direction, config player speed, direction times config player speed, and we were multiplying dir. Oh. So I wonder why it's not analog right now. Let's check config. Player speed is a float. Okay. I'm going to go grab a drink. I'll be right back. All right. We're back. So if we look at a controller, who's that guy that does has the input, the controller input stuff? I know Kenny has it, but there's a guy who has something that is used um I got to come up with some sort of naming for this. So let me confirm. I should be able to hold the input real lightly and move real slow. But no, we go straight to a run. Why is that? Player controller. Process and input. Let's print process dir. So what makes it into this on or off sensation? It's a new sensation. Process dir times config player speed. Let's math. Am I somehow config? I wonder, is this something to do with Are we doing... Do I want to divide? Let's did I just do division with my mind? Let's say we're 0.5 times 0.1, which is what we're doing right now. That should be right. Heretic. Whoa. See, why is it all or nothing? Do I need to calculate? How do we change Let me go. Dude. Dude. It's always nothing. Bro. I think we're losing the analog sensitivity somehow. Is it? Are we normalizing it somewhere? Is that what happens when we run it through A10? Something must be doing that. So we may need to send you're right. Let's take a look. Zaflins, how's it going? So we can use get axis, and that'll give us a positive or a negative number. And then there's action strength, which is a float. Okay, so we may end up we don't want to store an entire if we use 2 bytes or 2 bits, that gives us enough information. So 2 bits of analog input for velocity. I'm doing all right, Zaflins. How are you doing? So if we use 2 bits, we would get a number 1 to 2, so we can get a number all the way up to 4. 0 to 4, right? So that's or 1 to let's see. The first value is 1, the second one is 2. So we get 4 up to 4 possible values for analog input if we use 2 bits. Length is limited to 1. Oh, that's weird. We're not getting, so if we say get there are some velocity options here. Let's see. Mouse velocity. But they're calling it magnitude, I think, right? Magnometer. We're trying to. Returns the current value of the joypad axis. Get axis strength. Get action raw strength. Returns a value between 0 and 1 representing the raw intensity of the given action, ignoring the action's dead zone. One to 0 representing the intensity of the given action. In a joypad, for example, the further away from the axis the analog sticks, or L2, R2 triggers, it is from the dead zone. The closer the value will be to 1. Yeah, that's not what I'm seeing, though. Let me print it out here. That's what I would assume too. That's what I was assuming when I got rid of the speed stuff. Let me double check. Well, I know they're doing some weird stuff because it's a circular. It's not like. Close this out and okay, so we're pressing up just a tiny bit, and now I'm doing a lot. Easing up off of it. So I think that it's doing. I mean, given the name is. So what I was doing to get the value was I was using a distance. So I was saying direction value, distance 2, vector 2, 0. So that tells us how far away we are from that. That's how I was originally calculating speed because I couldn't think of how to do it otherwise. So now we should have a number that's a float. So I'm holding it down all the way. So it should be closer to 1. And now I'm easing up on it. And now we're about halfway. So that's how I was getting it originally. But I thought I could reconstruct this exact same logic on the other end now. But for some reason, it's not working. My guess is that when we A10, that this is doing something to, it normalizes something. I'm so confused. I are confused. Like if I print out, let's compare the two numbers that we can get back and forth from each other. So our original value is direction value, and we end up with input last, our dir last. So I can print this out by saying print OG new percent, and direction value is our original value that we had. And I can derive speed from that, fine. But then what number do we end up with when we say, God, leave me alone, dir last? Okay. Look at that. I'm easing it back down to center, and the number on the left, the OG number, is getting smaller, but the new one is only maintaining direction. So atan 2, let's look into this. Maybe we can get the same result without using atan and keep the velocity information. If we use, I wonder if we have to store the X and the Y. If I store those individually as 128, so if I use 4, if I separate them into 4 separate bytes, or sorry, 4 separate bits, to store 128 possible values to indicate that, and then we reconstruct the does atan2 normalize a vector? No, it does not normalize. Calculate the angle in radians. Well, yeah, it has to. The magnitude. So for my case, for my needs, it does. Right, because I'm trying to store the vector into an integer. So I'm trying to find a way to calculate it into it. So I found if I do an atan, I get a float, and then I can turn the float into an integer. So I'm wondering if I split it, And only have the angle, right? So I'm wondering if I store. I'm good. How are you, Red? If I store a number value that is a range of the X and a range of the Y from, if I store those two separately, my brother's having a bit of a crash out recently because his GPU is dying. Wonder if he can do that oven thing. There's always that oven trick for that stuff. Is it like the capacitors are coming off or something? You'd have to take the fan off and everything. Like the Hail Mary. The Hail Mary bake. Oven baked GPU. No, just black screening. Might not be the GPU. Weird stuff happens as he tried doing the, drivers, this and that. And okay, so let's try that then. What we're going to try, and now we've got another problem in front of us, guys. If we store, how do we in Godot? Again, this is all problematic because of Godot. All right. Give me just a moment. So how do we? Okay. So what I want to do is use two bits for the X value and 2 bits for the Y value. Okay. So we can turn that into a range and we can turn that into a number between 128, no problem. The real problem is how do I convert that quickly, into a bit mask? Because I can't just add X and Y together and then store that as a U8. I'm sorry, it would be 4 bytes for both. So a number between 128 on each of them. So if we do that, we can maintain the detailed information so we can reconstruct and have velocity still. But so we can still get because right now we're storing it into a float by converting it into angle information and then taking that float and then putting it in a value between 0 and 256. So we lose the information that lets us know how far in the vector it's being pressed, right? So we lose like the magnitude, right? So if we can just store that information, so we turn the two values of -1 and 1 into a number between 0 and 128 for both the x and then for the y, where we go -1 or 1, and I don't know, it depends on the, and 0 to 128. If we store these two separately, then we can redo everything we want. You just need a single float, but we're thinking in small. We're trying to keep the data small. A single float in Godot is 64 bits. That's 8 bytes. So we're trying to think smaller. Thus the problem. Godot uses doubles by default, yeah. No, ignoring what you're saying, Ghosts, here's the problem as I need it solved. I don't need any of that. What I need is, this is the actual problem. How do I take 128 in Godot, two values of 128, to be bit masked? How do I take that to, because I'm deciding that's the range that I'm going to use what you're calling the float and the angle, okay? Or the magnitude and the angle. We OR it. Take the first 128 and shift by 8. Yeah. Then the other. Then or the other 128. Oh, okay. Left shift, right. Okay. All right. So we're going to call this direction vector, or direction angle. Okay. And then that's the stuff I'm not familiar with at all. Okay, and so instead of referring to it as speed, we're going to call it magnitude. And instead of dir, it's dir angle or angle. Magnitude. So direction. So direction angle and direction magnitude. So dir mag. And then the other one will be cam angle and cam mag. Although I think with camera, we can reduce it down to just straight up angle. No, we still need magnitude because we have to know I don't know. We'll see. We'll see with camera. You're doing 128 values and the last or the first bit for X or Y indicator. So what we'll do is we'll use 128 for the angle. Actually, the nice thing about this is I can stretch, I can kind of squeeze things around because I might want more data for the angle and less for the magnitude. For instance, I believe that I only really need a number up to 4 for magnitude. And so if I have 2 bits for the magnitude, and then I have the remaining 6 bits for everything else, that gives me 1, 2, 4, 6, or sorry, 1, 2, 4, 8, 16, 32. I'm trying to do the math in my head. Because can I fit 48, 64, 69? 64, 128. So we have 1. So if I'm using 8, 8, right. So if we take 2 off, we get to 64. So I still, if I put this all in one byte, if I can do it in one byte, I think 64 might be enough for, because then we can store magnitude, and instead of using 2 bytes, we can store all of this in, or no, 128. No, how does that work? Why is it working out that way? Because it feels like we should be able to get a larger number than that. If I pack them into, because if I know that I'm going to use, like, we have 256 possible numbers, and I know I'm going to use I guess I'm just confused how I end up with more if I'm thinking in 128 and not in. So if I use 2 bits for magnitude, I can get a number between 0 and 4. And then I use the remaining 6 bits, I can get a number between 0 and 64 for the vector or for the angle. Right. It's still not bad. I still think it'll be enough. And this explains why in Fantasy Life has, can you guys guess how many different speeds it has? It has 4. 4 different speeds. And I know for a fact it does not do many degrees of rotation. It is locking, like it does tick. I can feel it. I can see when I'm moving the stick very slowly, the player will go like this. So even that, it's been reduced. So, okay, we're getting there, boys. I knew this was going to be a full stream to do this. But we did do some, we're getting, this is all becoming more rational to deal with. And I'm understanding it better, which is good too. It's a fun problem. There is little point in providing total rotation. Yeah. So 64 degrees. So if we take 64 and we split it 4 ways, right? So that's for each of our cardinal sections, that's 16 possible angles, right? Well, except we have north and all that. So, but that should be more than enough. It's about 6 degrees each. Yeah, that should be enough. I feel like that's enough. This is wild stuff. But again, we're trying to keep the packet size small so we don't lose the so that more make it through. We can make the game now, guys. That's not the problem. Making the game for me mentally is not a load as compared to trying to make sure that when we get this into people's hands and they're playing online, that it plays right. Like that's my main concern right now, because that's to me the make or break thing on this. Like, more importantly, you can now make another game. Let's do a different one. Any amount of them. For multiplayer, yeah. I mean, this is really, yeah, this does come down to the input packet buffer thing, what I'm calling it, that this will become any controller, right? So from now on, I have a system that makes really small, it makes a really small packed byte array that I can send across the line for inputs. My main concern is when people get this in their hands, it plays right. Banger. What's the I know a lot of people don't like Todd, what's the last name of the guy for Fallout and Todd Howard. Yeah, Todd Howard has a quote that I think. Well, I think he has a better quote. He has a better quote, and that quote is: "In video games, you can make anything happen, but you can't make all of it happen." It's something along those lines. You can do anything in video games, but you can't do all of it. Which is like when you're making a game, you could do anything, but you can't do it all. So you have to think about that from like what is it ultimately you're trying to do? Like what are you trying to make? Of the anything that you pick from. Yeah, screw those other Todds. I can't wait to play your game with my flight sim joystick or your recorder, right? The MIDI recorder. You can play it with a MIDI recorder. So I am solving a long-term problem here. I was thinking about like what could I do with this, and I was playing beat 'em up, one of the Ninja Turtle beat 'em up games that just came out, the Shredder's Revenge one. And I was like, I know what's going on here. Like I was playing it and I'm like, okay, I understand, I get it. Like from the networking side, I was playing with somebody. And I was like, their scope is actually a lot less in some ways because it's you're technically dealing with 2D planes. And like a bunch of other things get real simple. I made a data glove. Can try that. Hell yeah. Like the real power glove. Okay, so but to explain why I'm doing all this, the why is because the complication that I initially couldn't wrap my brain around of taking the camera angle information and applying that to our movement. We've done a lot to make that possible, namely a string of inputs coming across. Camera will be part of that. See, there's still a problem with this. There's still a problem with this. I can see it coming. And good direction will be der angle, and der magnitude. That's how we're going to reconstruct it now. So we're going to have to pull that out too. Typical hard worker just stopped in to say hi to my favorite streamer. Thank you so much, Typical. That's nice. I've never had someone. Well, no, that's not true. But that's nice. Thank you. Got him. But he's offline. Wait a minute. Wait a minute, Typical. I made an AI that did text to speech and speech recognition. Ran on a Pi 1 15 years ago. I'm a total geek. Dude, I wanna spend some time too, Bob, to build my own version of Alexa or whatever that's in-house, run in-house, instead of having this like permanent spy system installed in my house. I hope I don't get banned for 99 years. Huh? Typical. I'm so confused right now. I've been building those since I was like 15. I'm 52. By the way, is that Omarchi? Yes, it is. It's Arch BTW. I don't think we need speed anymore. Maybe we only need that from a data standpoint. I think we only need it from a data standpoint. Yes, we only need it from a data standpoint. So it's still dir last. We're still dir last, boys. Pre-configured. Yeah. I like it though. I like the pre-configured setup. I've never used Wayland. I've never used Hyperland, and I've never used Arch. So this is my first outing in it. But it made it really easy to get going. Dragon Naturally Speaking. Man, that goes back. I remember having to deal with that with CEOs all the time, getting that shit set up. Because they wanted to be able to just sit there like fucking Captain Picard and talk to the computer. One serious question, because I didn't want to spend the time getting it configured and everything. And I just, it really turned me off. I don't like navel gazing when it comes to, like, the problem with Linux is you can become like a major tweaker with it, and you're just constantly fiddling. And I'm too old for fiddling. Like, I can't fiddle with my stuff anymore. It just doesn't work the same. But no, seriously, I don't like messing with config files all the time and getting everything just right the way that I wanted, XYZ, blah, blah, blah. So somebody else kind of established their view on how it should be and said, hey, just use mine. And I was like, yeah, that sounds good. I remember my first time with Linux, NixOS, no idea what was happening. I wrote a script that accidentally ran rm-rf. Yeah. I just, I mean, I did that for my, like, when I was a kid. I was constantly just tweaking configs and just messing around with that stuff. And it's just, ultimately it's like it's nice, but the only time I really care about doing that is when it's going to get me to where I need to go. Okay, so sorry about that, guys. Let's get back to work. So we end up with, we determined it was 64, right? So we're going to get 64 possible angles. And then we're going to turn the magnitude into so we're going to do the same thing here, round I, but we're going to multiply this by 4. And then that's our magnitude. Der magnitude. And this is an integer. Okay, so 64 possible directions, 4 magnitudes, and then we're going to slap this into get direction. So we say direction, angle, comma, and direction magnitude last, which we can just call direction magnitude. So dir angle shit. See, fuck. Direction value. Dir value. Let's call it dir vector. Normally I don't like having variable types in the name. Okay. I'm the one who's supposed to break my computer, not some guy updating his config. Yeah, I could see that. Yeah, no, I get that. I think once I get more comfortable with everything, I might roll my own thing. So now we need to store these bytes. These two here, the dir angle and the dir magnitude. So this is where we need to do the bit shifting. So how do we OR? We need some value that we're doing in the first place. The bytes, dir bytes. We did something like this already with our pack, byte packer. Like that. So if we OR it in to dir bytes, and we say dir bytes or dir angle. Can we do it in a row? There's no way, right? No. And then we say dir bytes and we do it again with the magnitude. Okay, so we should have something now that we can encode. Dir bytes. Dir bytes. Let's print out dir bytes. And see if we have something. Something useful. And now we're broken over here because we have to kind of unwrap it all. And then send it over into, so this is not dir int anymore. It's dir bytes, just like we had over on the other side. And then now we have to unpack the ORs. So how the fuck did we do that? The other thing too is the size of the we have to do this to it first. So we need to, this is a little more complicated. Let's steal this from byte packer. So this is where we shift it. We shift it over by the amount, and then we OR the rest in. So okay, I'm starting to understand this stuff. I'm starting to understand it. And bit left and right shift, it makes sense. You're literally just moving the bytes around. It's coming to me. It's coming to me, guys. It's coming all over me. It's getting there. All right. So what we would do here is we take its current value, but do we want to do this after? Yeah, we want to shove it over. So technically the first thing we can do is just assign the value. So we put the angle in the bytes initially. And then what we do is we say dir bytes equals dir bytes, and we push it over by the amount we want. So dir bytes, and then we're going to left shift it by how many? What did we determine it was? 6 for angle. That gets us 64, right? And then we OR the magnitude in. Is that right? So we put the initial dir angle in, and because we know that it's a number that can only be 64, we shove it over by 6. So then it becomes a bigger number, really. and then we insert or we drop in bytes at the beginning because of the total number that it could possibly be, which is up to 4. Does that make sense? I think that's what I'm doing. Okay. I think that's what I'm doing there. Why they're named this, I have no fucking clue. I'm guessing that this has to do with some this goes back to like Turner, or who are the other mathematicians before computing even existed. I'm guessing that these names came before computers, where the Turing machine or something like that, it probably came from something like that. And I think if I understood that, if I understood the etymology of those terms, that might help me understand it better. Like XOR, or, and if I could find the original papers where those words came to exist, I might understand it better. Exclusive OR, yeah. Like, where did those come from? And I'm guessing that those the concepts of them mathematically or whatever came to exist before computers did. They're from the literal logic, right? But what I'm saying is someone created that logic somewhere. Set theory. So who made set theory? Was that Alan Turing? Well, yeah, but I find that if I understand the why it's called that, it helps me a lot. Set theory, the universe. You son of a. Who created XOR, OR, and? Are created by one. So George Boole in the 1800s represented logical truths with XOR. So this comes from logic in language, right? If it was a philosophical thing, this is coming from logic, not and by logic I mean the philosophical the way that you can convert an argument into a mathematical problem and solve whether it's true or false. Boolean algebra, George Boole, establishing and, or, and not operators, laying the groundwork for all digital logic. So it was George Boole, 1800s. Long after that person was dead, created the foundation for which all computing derives its so how we were able to take electronic signals and turn them into what we have. Now, did he steal that from a Muslim? Because generally that's what we find out in mathematics, is it already existed long ago, long before that. And he just happened to be the first white dude that that wrote it down. Let's see. No, the way in mathematics, you know that in the old, it came to be from a person that wasn't white necessarily, is it doesn't have a name that's after someone. If it has a formal, like, weird sounding thing that doesn't come from somebody else as far as their name, then you know that they washed it out and it came from somebody who they didn't want to name it after, basically. That's usually how it works, because all that stuff came to be long before we came to be. So they just got rid of the person's name. They didn't credit them. That's usually your hint that it was from because all mathematics comes from somebody else saying, what if we did this, and let's try this, and we'll use these symbols, and all that kind of shit. So it all could be credited to this person was the first, and we'll call it this. But then sometimes it's called just like Pythagorean theorem, right? But then there's other stuff that we call, and it's clearly not named after anyone. I remember watching a video about that. It was really interesting. I don't blame us for it, but it's interesting how that works. History names the winners. Okay, so let's not process. So right now we're just going to return an empty vec2.
I can't believe you've done this.
Excuse me. And then we need a der magnitude. Der magnitude. Thank you for the follow. Hasp. Hopefully I'm saying that right. I don't know. Hasp. Okay, so now we need to unpack the bytes. So we have the bytes here. So how do we do the opposite of what we did above? Let's see. So we want to do this backwards. Guys, how do I do this? I guess, do we literally start in order backwards like this? And we... do we bit shift? I'm unpacking. So this is the order I packed it in. This is how I packed it. I guess if that's the term. I don't know if it is. And so now what we want to do is we need to do the shift first because we need those clean bytes, right? So no matter what, we have to do the shift first because we have to get rid of those bytes to get the other value. So we take... So this is a var, and this is angle. Dir angle is an integer. And we take dir bytes, and we bit shift, or we shift to the right. So we shove those bytes over, and now we get the angle. So now that we have the angle, we can then... How do we take those bytes and clear them? So we need to... I'm going to comment these out. So now we have this. This is our number that we want. So we for sure can get the angle really easy because we just shift it over and that gets rid of the other ones, right? So that's easy. So if we take... And we start with another clean thing we're going to call var dir magnitude, which is an integer. And we say that it's dir bytes. And now we can take that and do some things to it. So right now it's wrong. It's including the bytes of the angle and the magnitude, but we have bytes. We have the angle bytes now. So how do we... How do we just clear the very left 6 bytes. I guess we could say, now that we have dir angle, I don't know. I'll call something clear bytes int equals dir bytes 6. So then we took the angle out, and now we're putting it back into this thing called clear bytes, and we're shifting it over by 6. And do we not need to, do we do the bit shift by 2? 2 to the right? Since we did 6 to the left, we do 2 to the right to get us back over to, is that how we do it? Or do we shift 6? We shift 2, not 6. We shift 2. So not 6. I was thinking size, not number that we shifted over to. So then we insert this in by bringing it in and shifting it to the left. Now I don't know if I'm doing the right shift right. I don't know if I do 2 on the left with the arrow. So then we have these bytes, and we can flush out these bytes from dir magnitude. So dir magnitude. Now, how do we XOR? Is that how you if the bytes are the same, then if there's 2 booleans, it becomes a 0, or if there's true, then they're false. So if I'm packing, say, packed oh, Zaflins, I can't. I can't, Zaflins, I can't. I don't think we need clear bytes. So we shift by 2, right? Because we're only shoving it over 2 times. We're thinking of it as 6 bits, but we're shoving over 2 bits so that we have room for the 2 bits to then, that's what we're doing here. We're ORing the 2 bits in. Okay. So then angle is, from our bytes, we right shift 2, and that gets us the right angle number. And then for magnitude, if we take and we sign it as bytes, dir bytes, then we still have a little bit of work to do to unpack that. So we say, do we do the same thing again? I need to look up. You can check out some code. Yeah, I mean, if you have something you can point me to, we're getting it. To turn certain bits on, the bitwise OR operation can be used. Therefore, to make sure a bit is on, OR can be used with a 1. To leave a bit unchanged, OR is used with a Y. For example, masking on the higher nibble bits. Oh, that's cute. I didn't realize that when you're talking about. So these are nibbles that I'm dealing with. That's cute. Let me look this up. Nibble. I didn't know that. Aggregation of 4 bits. Okay, so it's not a nibble. Oh, but there's probably. What about, is there ones for like 2? A byte is 2 nibbles, and therefore a value can be shown as 2. So what's 2 nibbles called? Or what's 2 parts of a nibble called? Anyways, that's cute. Okay, masking on the higher nibble bits while leaving the lower nibble bits unchanged. So we OR the 2 together, and if... Okay, so that's not what we want to do. Masking bits to 0. More often, in practice, bits are masked off. That's what I'm trying to do. So that's ANDing. So if I AND... All right. I'll be back. I'm going to get some lunch going here. I'll be back momentarily.
Huh?
That's Nathir. That's Nathir. All right, we're back. How do I know that's Nathir? How do I know that? How? Nathir always comes in and claps himself into the room. Needs to have the... okay, so I'm going to eat some food. Let's put on something to watch. Does anyone have any video recommendations for me? Let's see. I was watching... All right, somebody throw something in the links. You should scroll up and check old chat. Oh, Dibit is 2 bits. Tribit is 3. Okay. Was there an episode of Quantum Leap where Scott Bakula is expected to kill baby Hitler? Because that is absolute negligent, if not. The reason why that can exist, Rig, is because I believe that the character of Sam could only go between times where he existed. He could only leap in between his lifetime, if I'm not mistaken. Nope, you're wrong.
The opposite of any work.
I am? Wasn't there some constraint on where he could leap, like time-wise? Oh, Nightbot caught Nathir trying to rickroll me. I put that there on purpose.
The biggest assumption in modern technology is wrong. Everything we build, phones, laptops, even the entire internet, is based on one belief: that reality fits into zeros and ones. Right or wrong, that is perfectly logical. But that belief falls apart in the real world, because reality isn't perfect. It's chaotic, noisy, and unpredictable. In biology, cells divide with tiny errors. That's how evolution happens. In the brain, neurons fire irregularly, and that randomness powers creativity. Even stars explode, and from that chaos, new elements are born. In nature, chaos isn't
Oh,
the
Ghost did the
enemy.
rickroll attempt?
It's the engine of creation.
Nightbot's too
And
slow.
maybe it's time machines learn the same trick. I'm a chip design engineer turned tech founder. And today we will dive into the most mind-bending idea I've ever explored. An approach to computing where physics does the math. And it all began over a century ago in a very unexpected part of the world. Back then, the world was very different. There were no computers, but the same question was already haunting science. Could we ever truly understand the chaos around us? Back then, many scientists believed that the universe was perfectly predictable, which means if you knew the exact position and momentum of every particle, you could estimate, you could calculate everything that could ever happen. This idea came from the French mathematician Pierre-Simon Laplace, who imagined an all-knowing intellect, later called Laplace's demon, a being that could see every atom in the universe and compute the entire future. No mystery, no randomness, total determinism. Sounds familiar, right? That's exactly how modern binary computing treats the world today. And this belief in a perfectly deterministic universe ruled science for nearly a century, until one man dared to challenge it. It was a young Russian mathematician called Andrei Markov. He didn't believe that universe was a perfect machine. Markov saw randomness everywhere, in nature, in music, in language, and he refused to ignore it. So he became obsessed with a question most scientists avoided. Can randomness be predicted? He became convinced that chaos wasn't chaos at all. It followed certain patterns. So he built a simple
Cows?
experiment.
Oh, chaos.
He took something that looked unpredictable and measured how often one state follows another. Today is raining. And if today is rainy, there might be 70% chance it's gonna be raining tomorrow. And might be 30% chance it's gonna be sunny. And he didn't need the entire weather history for that, he just needed the current state to predict what is next. And then came the breakthrough. Even randomness had structure. From one moment to the next, there was a fixed probability of moving to each new state. Step by step, those probabilities formed a chain, one that eventually settled into a stable pattern. This was a moment when he discovered what we now call a Markov chain. And this gave science something priceless, a language for structured randomness. It became a universal tool, a way to model evolution, molecules, weather, economies, and even intelligence. Just imagine, decades later, the same idea powered things like Google's PageRank and DeepMind's AlphaZero. It's crazy how this simple idea ended up changing everything. And if you watch till the end of the video, you will see it's even changing the computing. That was for the first time when the world seen an opportunity to predict unpredictable. Not exactly, but statistically.
Want to learn how to clone yourself to make talking head content like this?
And then this idea collided with the most dangerous scientific project in history: the race to build the first atomic bomb, the Manhattan Project. At this time, physicists were racing to understand the most chaotic process on Earth: a nuclear explosion. The equations behind nuclear reactions were chaotic and basically unsolvable by hand. But what if they didn't need exact numbers? What if they could just sample reality, the way Markov had done? A nuclear chain reaction looks impossible to predict. Each neutron flies off, splits an atom, and releases more neutrons. Maybe triggering another reaction, maybe not. The number of possible paths is just astronomical. So how do you simulate chaos like that? At Los Alamos, one of the scientists, Stanislav Lam, had an idea. What if, instead of solving everything exactly, we could sample randomness itself? In practice, that means if you repeat something random many times, the average result will reveal the true value. Look, if you flip a coin just 5 times, you can get 4 times head and 1 times tail, which may look wrong if the probability is 50%. But if you flip it 5,000 times, you might get 2,507 heads and 2,493 tails. And that's 50.1%.
I was
Much
making cow
closer to
jokes.
reality. And that's the law of large numbers. The more trials you run, the more accurate is the result. That's how Stanislav Ulam realized that instead of solving every equation exactly, you can run thousands or even millions of random trials and then average the results. Do that and you can predict the outcome of chaos. This was a genuine breakthrough. He brought this idea to his friend, John von Neumann. Yes, that von Neumann, who just designed the first computer that can store and run its own programs. Which is remarkable because this is the same blueprint behind every computer today. Together, they turned Ulam's hunch into real mathematics. They called it the Monte Carlo method, after the casino in Monaco, because it was just like gambling. Randomness, big numbers, and the law of averages. This allowed them to understand how nuclear chain reaction would behave without tracking every single particle. And that proved something profound. That randomness isn't enemy. It can be a powerful tool. The Monte Carlo method spread like wildfire.
Yeah, cool.
Zed, how's it going?
It's cool. It's not cool.
Thank you for the raid. Do a shout out. It's going. We just realized how we can grab more data out of a byte for analog input than we realized, because I'm an idiot. So we're gonna use 6 bits of a byte to get 64 possible angles, and then we're going to use 2 bits of that to get 4 possible magnitudes. And so I'm now trying to learn how we can do this through anding and oring. We've got everything packed. Well, I just am trying to, with Godot's scripting language and everything, I'm trying to figure out how I unpack it all. So that's where I'm at right now for this. And then we're going to take this same stuff that we've learned from this and apply it to the camera input information as well. Yeah, let me, Zaflins, I'll take a look at that in a second. How's your stream, Zed? Bit twiddling. Ah, yes. I'm sure they know their bit twiddling well. Yes. Let me see. Mine was good cleaning up the Vulkan code to understand it better. Zed, it's wild the stuff that you do. Yeah, so basically, so what we've got is we're we have an angle that we're assigning to our and I guess it's dir byte because it's a singular thing. It's 1 byte. So we put our angle value in, it's an integer, into the dir byte, and then we shift it over by 2 so we have room for the magnitude, which is a number between it's a number up to 4. And then we OR the magnitude into that as well. And now we're trying to do the opposite. And my brain is exploding. So with angle, we can grab it by taking our byte and shifting it over by 2. That should give us an angle. And now it's doing the opposite of the OR that's making my head explode. So how do I clear the 6 bytes to get that? So maybe it's XOR okay. So if what if it's 0? It does the opposite. Bit unions or something like that, where you can set the big int and then get the bits via different names. I don't think there's anything like that. I have we can pack bytes, but we have to I think we have to pull everything out by let me show you what we've got. We really only have well, there's a not. I wonder if we can do not. So we can do bit shifting. We can do a bitwise not. We can do and XOR or is it XOR? Did we say XOR? So what does OR get us? Masking. So that masks on the higher bit. In this case, this is kind of a bad example. To turn certain bits on the bitwise OR operator can be used the principle that an individual bit Y and Y OR equals Y. Therefore, to make sure the bit is on, OR can be used. Masking on while leaving the lower nibbles 0, 1, and 2, and 3 unchanged. Bits are masked off. Why are we getting 2 examples that are the same here? When a bit is AND with a 0, the result is always 0. To leave the bits the other way they were originally, they can be AND with 1. Toggling bit balance, merge bits. Sometimes selected bits must be copied without altering other bits in the register of storage. This expression Okay. So is a bitwise not just the opposite? It inverts the bits. Okay. So if we do that, okay, so if we OR a knot of the original angle bytes that are shifted. Oh my God. Okay. If we OR a knot of the original bytes, but we only want, okay, so this is where it gets weird. So we want to shift. Okay, no. So we want to, okay. I think I have it. Dude, I don't want to give you money. Leave me alone. Oh my God, for crying out loud. Who let Christmas be this close? Tell me about it. All right, well let's just see if we're getting angle right. Cuz I'm pretty sure I'm getting that right. And we're just going to pass 0 for magnitude. Cannot use subscript operator on base type int. What? What are we talking about? They both want ints. Dir angle. There is no dir angle. That's why we're complaining. It should just be dir. Okay. Here we go. All right. Everything's going to be broken right now. Please excuse. I don't even know if this is going to run. I feel like living in the 14th century. Windows just gave me an error of a command line being too long. There's a freaking limit, and it's short. A normal chew. I leave in 5 minutes and everything is on fire. Not on fire. We know where we're going. We always, the good news is we know where we're going. All right, so we have to update client. Let's go ahead and do this. And going up here. So we're not having speed anymore. We're going to call it magnitude. Magnitude. Or not even that. We don't need speed anymore. We don't have a need for speed. 32. IP buffer speed last. We don't have speed last. We're not going to pass speed into processing and the input. We don't have a need for speed. Is that, they made that into a movie, didn't they? The video game thing. Tried to make it the next Fast and the Furious. But that's, what is that, Top Gun? I have a need for speed. Line 90 on controller. 90 GG. Or, yeah, 90 GG. Spad. Var. Let's just comment this out. Animate movement. We're not going to do that. All right, we're breaking everything here, boys, but we're trying to get smart. Too many arguments. God, Zooks, boys. I wish this compiled. I strongly wish this compiled. Too many arguments, once again. 85.
So you're just an old hacker like me, but disguised as an idiot.
Exactly. Connect client. Okay.
What the dog doing?
Your mom. He's downstairs in the dungeon. I got to start putting him up here.
Just be yourself. Be yourself. Be yourself.
You guys are embarrassing me.
Be yourself.
Zed's audience expects no brain rot, and here you are. Just
Fartality.
Shh, guys, play it cool. Play it cool, dudes. Come on.
You okay, guys?
Shh. Okay, so now we're printing Durangle. All of this to see if we're getting something
okay,
we can
guys?
use. Durangle. Ah, it's a Durangle. Here we go. What in the... Oh, decode pack byte array is never going to fire. Because we're not connected. So let's do it here. Der Engel. Print. Let's see if we have a number first. dir angle %s and dir magnitude. Magnitude. Magnum. It's glorious. It's magnum. I see a lot of code and little comments. We have to create busy work for our workers. So this one or is it this one? There we go. All right, so we're getting magnitude. And then releasing slowly. Magnitude's decreasing. Okay, so our math on all that is good, right? So we know we know we're right there. So now let's look at der byte. Der byte. Der byte. So this should be getting encoded in something. Der byte. So once again, what is that? Der interessante. Writing design, and don't forget UMLs or UMDs. What do they call them? You got to do a lot of diagrams. The higher ups love flowcharts. UDP. Maybe. I don't even know. Something like that. Got to have them flows. All right. Der byte is looking like something. Now, if we use our brain, I could figure out where 256 should be. I know we have to be holding down the thumbstick all the way. If I press up, our angle is 60. So we want to get to the highest possible angle, which is 64. And then we should get to a number that looks like 256. $260. Something has gone horribly wrong, ladies and gentlemen. Hang on. Are we too large on the magnitude? Because it's 0 to 2. It's between 0 and 0. So 1, 2. So we can be as high as 4, but do we need to be from 0? Is that what we want? So it's really 3. Let's see. Because 0 is a possibility. I'm moving the thumbstick slowly. Trying to get it over. $255. That's as high as we should get, right? Yeah. So it needs to be 63. So it's -1. Okay, we got it. So my math that's a little bit off, but now we're good. Olex is here to complain. Man, Olex controls so good. master controller. Give me that 256, baby. $255. That's it. Okay. So 255. So now we know our bytes are bitted right. Let's try to do our decoding stuff that we were doing here. So we're just going to do it ourselves below here just to get this right. And then we'll do the work that we need to do to put this into the rest of the game code. So again, why are we doing all this? We're doing this because we're sending inputs in a stream across the internet to the server client. And we want those to be as small of packets as possible so that they make it across the pipe more often. Because we're sending them unreliable, unordered. So, thus, we are we'll call it decoded byte. So let's see if our angle neuter angle decoded dir angle equals new dir angle. So this is us unpacking it. Offset is ring index. And actually we want to do this after we encode it. So let's put this here first. And then we decode it. We use ring index for the offset. Which I guess is supposed to, we should call it ring head. Decoded dir angle is correct. Okay. So now we have to get the magnitude. Oh my God, all this bit shifting. So the so the way that this is we have 6 bytes, 6 bits. I'm going to do that forever, and I'm sorry if it pisses you off. We have 6 bits. Let's change our grid. How do we do that? There's a way to do that. You guys know how to change the grid size? There's some way to do this in here. Is this it? I don't know. I remember finding it once. Anyways, so we have 6 bits that are used for the analog the vector 2 direction, and then we have 2 bits that is the magnitude of the input. 8 jiggly bits. We just learned that 4 bytes can be called a nibble. We didn't know that. So now we know that. Sorry, 4 bits. Jesus. I'm going to keep doing it, boys. 4 bits is a nibble. Half a bit. I had shot bots. The only people that I'll time out or ban are people that we don't turn on ourselves here. So you can call me an idiot all you want, but all right. Six, and then, okay. So here's what we've done. We've shifted these over. So if we have 8, if this is 8 total, I'm just put it like in a container. We've shifted these 6 bits back over here, and that's how we're getting the accurate number. So here's what we have to do. We have to null out this value, these bytes from this position, these 6 bits here. Okay? How do we do that? We have them. So I think we need to flip them to their opposite, right? And then we OR them out. Or no, we not them. No, we OR them out because we bring them in. So what we need to do is flip them first, and then we need to OR these bytes into it, flip these bits first, OR these bytes into it, or flip these bits and then OR these bits in, and then we go through and we not. Do we not it? Is that what you do? And it. Can we do that? Can we do that, Ghost? I don't know if Godot lets us do that. Can we actually write out the bit mask like that? Because what you're doing is you're literally writing the masking out. You can? In GDScript? So I spoiled the fun of this in Discord. Okay. Say again what you wanted. Okay. Basically, I would like to null. We have 8 bits. I want to zero out the 6 bits on the left. So 3 through 8. I don't care what they are. I do. I want them to be nothing, so that we end up getting a value calculated from a number calculated from two bits. A bitwise AND operation with a mask that has zeros in the positions of the bits you want to clear. Bitwise. So this'll Poseidon. This'll work in GDScript. So then if I go var new dir magnitude int equals 0b or ob, or is that a 0? 0b 0 0 0. So all the ones with 2. 1, 2, 3, 4, 5, 6, 7, 8. And then we AND.
I can't believe you've done this.
And we're ANDing our decode byte. Okay. Tic Tac Whack, thanks for the follow. $12.09. Give me a second. I don't know how iHeadshots is even able to talk in here. I have it so that I should have it so the accounts that are just created can't talk. I'm going to ban them. I'm sorry about that, Ghost. I mean, again, you can pick on me all you want because I am an idiot, but we don't do that in chat with each other. I draw the line somewhere. I'm trying to find him in the chat. Oh, it's way up. Did somebody already do it for me? Thank you. I'm sorry if your first chat is going to be that you're out. I'm not even going to play games with that kind of stuff. I don't have time for it. We don't have time for it. Okay. So now we have, where are we? So now we have dir angle, and then we're going to do dir mag. Nymphus says that's the answer. Okay, let's see. Let's see what we're getting right now. We're going to close out the other clients. We got it. All right, we got it. Okay, so this is what we're going to do to decode this. All right, so we know we're encoding it proper. And now we're going to take this work that we did here and we're going to move it down to where we decode it from. So there's our dir byte. And one thing we want to make sure that is that we're always drawing from we're creating the input always with the identical method and approach so that when we're doing this locally or when we send it across the network, the result is identical. That's the key thing to all this. Otherwise, it's all for naught. So now when we go over here and we say get direction, this is where we can restore everything to its original loveliness. This is the math that we're going to use to produce the output that we want. So if the value is 32, then we're 0. Otherwise, we're going to do all this math that we had before. But we do need to apply some stuff here, and then we need to do this work here for our get direction in the first place. So decode byte, so dir byte. dir angle, so we can get rid of all this. Get rid of all this. And instead of ring index, we're calling it offset. Okay. So we get these 8 bits. Dude, I'm going to always say bits and bytes wrong for a long time. And I apologize. It's just, it's really throwing me off. Get direction from dir angle. And then dir magnitude. Hey, handsome, how you doing? What's going on, little man? What are you doing? That's super cute. It looks like a... Doesn't it look like a... Okay, math nerds, I need some help here. How do we take a vector and reintroduce... How do we take a normalized vector and insert a magnitude into it? Multiply by the magnitude. It can't be that simple. That's it. All right. So that's how we zeroed out when it's so dir magnitude. So return. So the magnitude's 0, it's going to be 0. That solves that problem we were having. Return dir magnitude times okay, but we need, so dir angle we need to turn into a vect. So we do vect2. So this becomes var direction vector 2. And this is how we get it back. And we're not doing 256, we're doing 63. Okay, so this reconstructs the direction. And then we return dir magnitude times direction. And then we get rid of the rest of this. Okay. Wait. We have to normalize. We got to magnitude should be a number between 0 and 1 in our case, right? So I have to normalize the number. And what I mean by normalize is we're taking a number between 0 and 3, and it has to be between 0 and 1. Right? For our needs. Scaling by floats can be a bit wonky. So how did we get the number in the first place? Right. Well, I'm still going to do it. It is, I guess you could think of it as a magic number, but I know that I'm working with I know that I'm working with I'm doing bytes. So when I see 63, I kind of know what that means, right? I frankly wouldn't know what to call it if I gave it a name. I guess I could say direction angle bytes a bit. Direction angle. Byte number. I don't know. I don't know what I would call it. Max direction angle byte bit something. Then just do -1 full byte. I could do. Does Godot? Maybe Godot already has some. Maybe Godot already has some enums for this, right? Where's their list of their enums? Does anyone know where that is in the docs? I remember finding it somewhere. Like maybe there's a U8 enumerator. I guess this is it. Poor JD. JD's trying to make us laugh and we're just ignoring JD. He's like, pop, pop. He comes in with a community reference and everyone's like, so the bytes, so the bits, so blah, 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 blah. And he's like, community, guys? All right, we'll find Nymphis. Leave me alone. We'll do it. Jeez, Nymphis. Is there a way we can create global constants where I don't have to have a damn class name to reference it with? No. I guess we could do it in here, but then, oh, you know what? We do have, hold on now. Hold on. We did do this. Extends packet. We're inheriting, guys. We're using inheritance. Const. So we could do const U8 equals 64. Or no, U8 wouldn't be. The max number for that, see, it wouldn't even be a U8. I couldn't do that. This is more like a U6, right? Which would be 64. So we'll just put U6 here. This is so stupid. See, this is why I hate this. And now I have to do, but see, now we're doing math when we didn't need to. Because now I got to do a subtraction, right? We're in a scripted language. We're punishing ourselves with performance so that we have readability. Godot only does 64-bit. Everything is a double. It's C++. In the engine side, it's C++. Everything's just double. So every number, any number in Godot is 8 bytes. All right, we'll do that. But see, then we're going to forget and we're going to want it to be the number 60. We're going to want it to be the number 64 sometime. And then it's going to bite us in the butt because we don't see the number. I don't know. I have a weird, I'm starting to have a weird relationship with magic numbers for certain things. All right, so there's our magic U6. I almost feel like it does exactly what a magic number is supposed to prevent from happening. Okay. So anyways, back to magnitude. Magnitude, we're now going to translate into a float. Float equals, so we needed to get to a number between so we divide it by its, see, now we're going to get to the magic number here, which is 3. All right, so we have to do the same damn thing for this 3 here, which is really a U4, or no, a U2. Sorry, it's a U2. So go back over here to, let me get rid of this. Let me get rid of this. So now we have a const of U2. And this is a 3. And one way to kind of make this easier for me to grep is, well, I'm not going to do it right now, but we could just do, how do you do it? You left shift. So you say 1 left shift 4. Right? Or something like that. And then you could do the same for, but anyways, U2. Hello. Hola. To a place called Vertigo. Jesus. ¿Cómo está? Oh my God. This song's amazing. Oh, this is the greatest song I've ever written. Is he Irish? The YouTube Bono? Is he Irish? Oh, this is the greatest. Now I'm Scottish. I need to pick a fucking accent. Why am I going Scottish when I'm trying to do Irish? What's going on here? I was never a U2 guy. I'm sorry, I didn't get it. So now here's the other problem though. See, this is where everything kind of, the magic numbers really are going to screw us up here, bros. Because we are dividing, this is a integer. So this needs to be a float. And I guess we can just cast this into a float as well. Cast it into a float. Be rid of it. No. Okay, so now 3, the blah, 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 blah. And then we get direction, blah, blah, blah. So when we do this, let's just, Irish accent, guys. How do you do an Irish accent? I have to think of Lemmy. I have to do an impersonation of Lemmy. That's hey you. You guys keep coming in, letting the dog in, opening the door, the music's blasting, and then you don't shut the door. So I'd love for you guys when you do this to please shut it all for me, okay? What's up?
Mr. Pig.
Oh, you have your necklace. Yeah.
Mr. Pig wants you. Like, hi, Papa.
Hi, buddy. I gotta get. I'm trying to work. Trying to work, Mr. Piggy. Mr. Pig.
Incoming dog.
Mr. Pig. Oh, Mr. Pig. Oh, yup, yup, yup. Oh, I love you too.
Look at this pug face.
He's so toasty.
Yeah, he is warm. Hiya!
Oh, Christ.
I will destroy you. Delicious Papa.
All right, I gotta get back to work. Okay, sweetie.
Like, no, I want Papa. Over here, cutie patootie. He's being so cute. Come on. He's button. He's button.
What was your suggestion? Oh, that's not a bad idea, Ghost. I like that. I missed it. I missed it in all the chaos. What in the actual fudge is going on here? If we try and divide an integer by an integer, will it give us a float back? I feel like I've run into this with Godot before, where it just rounds everything and tries to keep it. Divide by 0 error. Which doesn't make any sense because U2 is not. Is not 0. Let's just type it in as 3. So does the left number need to be a float? Can we just do 3.0? What's INF? What does that mean? That's an error of some sort, right? It means infinite. Floating point infinity. When the divisor is 0. So we have to do a check to make sure it's not 0. So if their magnitude equals 0, var magnitude equals 0.0 initially. So if it's not 0, then we do this math here. And we say U3. U2. Hello, hello. We're inverted. If I go all the way to the end, we go slower than if I get closer to the beginning. Oh, that's because of the math we're doing to multiply the magnitude. Okay. So guys, we are multiplying direction by magnitude. Are we sure it's multiplication? Which is fine, just delete from. Dir times 1 divided by mag. Why is it? Yeah. So if we say magnitude is 1 and we multiply by, we're half, our direction is 0.5. And if our magnitude is 0.5 and our direction is 0.5 on one of the axes, we then... So what's the problem here? Is our magnitude... Let's see what the number is as we go. Mag 3. So we're still technically the wrong number. Magnitude equals dir magnitude divided by... So how are we getting 3 here? Does this need to be a float? Let's make them all floats. Make you a float. Everyone's a float. Dir magnitude is a float. And dir magnitude is 3. You do 3 divided by 1. But we're trying to squeeze the range between 3 and 0 to 1 and 0. So dir magnitude is a number between 0 and 3. And I'm just now realizing the reason why we have 4 different speeds in Fantasy Life is because there's also a run button that works like a multiplier. Lerp it. Why not just do dir times dir magnitude? Because I need the magnitude. I mean, I guess I could do that. I'm trying to make it so that I can do the speed stuff on the player controller side. So I'm trying to get it into a number. Fix or go to Joe. Huh? Lerp it? It's valued. It's the 3 is on the other side? Really? Doesn't feel right. Oh, I'm thinking multiplication. So if we do it this way, I need to multiply it. No. I don't know, boys. All right, let me move this over. That won't work either. God, I'm such an idiot when it comes to math sometimes. So if we go like that, and then I almost think programming without knowing math, but doing math when I learned programming is potentially what screwed things up for me. Because it's like, oh, I could always just try it in code and then find out. We got it. We got it. We're golden. We're golden patodin. Thank you so much. Now, here's the real question. Can I do this with just integers? Integer division, the decimal part will be discarded. So if I say a float here, then we're okay. Okay, so let's get our speed to be speediness. Config. Now we can mess around with player speed. Let's bring it back. That's a constant, though, so we can't edit it at runtime, which is annoying. There we go. And now if we slow it down. And now let's put this back into the animation of the player. So we go back to player controller here, and then we're going to bring the speed in. So this is funny because now it's almost like we want to do this math in the player controller and just pass this stuff through the magnitude and the, because we end up having to do the same math twice. So maybe we do keep speed, but we'll call it magnitude now. I suppose I was trying to get it into a single vec too. I suppose you're right. But another reason why I want it as a number between 0 and 1 is because that's what I send to our animation. I still have to do this math at some point because I use it for the blend between 0 and 1 that we need for animating speed. So I still need it. I eventually need it into that. I need it into that. So what we could do then is I'll throw magnitude in here. As a float. And we'll go ahead and use this for animate. And then we'll use this in here as well. Now a bunch of stuff is going to break, but we'll fix it. Yeah, you know what? We could just do a comparison. I could do just a match statement. That's probably faster. Well, that's probably faster. Right? So we'd just do a match statement on dir magnitude since it's an integer. I suppose we could do that. So get direction doesn't need magnitude. It needs angle. And then we just return this. Like so. Okay. And we don't need to pass magnitude. And then we need to record magnitude up here. It's coming along, guys. I appreciate the open conversation. This is the kind of constructive dialogue. And it's not backseating. To me, this is not backseating compared to now type this, now type this. Now, like we're all talking. You're trying to figure out what I'm doing. I'm trying to figure out what I'm doing. This vector floats here. Dir magnitude last. It's a float. Roger, what's up? It's really a fun problem of discussion. I like it, yeah. Yeah, we're getting rid of that range. We're saying from a design perspective, we're conceding certain things about the design of the game with relationship to how we're doing the netcode instead of, oh crap, it would have been nice if we had done it this way, but we're not, and so we're going to end up doing it that, you know, instead of wrapping the netcode around this later, we're building the netcode out and thinking about the problems that come with what we're trying to achieve with the netcode and designing a game and making conceits on both ends. And so they both shape the design of the other in some ways. But one of the things that's absolutely shaping the design of the game within regards to netcodes is we do want to control the number. We do want to constrain the number of bytes that we're sending across to be able to have them be small. And so that creates certain constraints that then force our hand at the game design part of things. So, and all of this for controller input. This all doesn't even matter if we were just to use WASD, right? And then what? We have shift as a like a speed modifier or something. But that's also it's crazy how you start to understand why a lot of this stuff is the way that it is and how it shapes the way a game plays. Because the conceit with the run button is that somebody might be on computer. That's why they have the run button. And that's just like a wild thing to realize. Because otherwise, if we knew if it was guaranteed analog input, the idea of run wouldn't really be necessary. But a lot of people like that extra, like you push the button and it makes it go even faster. And so that might be a design choice as well. But it's kind of interesting that you don't really need it. Hey, sweetie.
I just wanted to check in. The kids are wanting to do their switch. Is now like okay, or did you want them to wait until you're done? Or
I don't know what time it is.
it's
Damn. Okay.
or did you want me to take them?
No, it's fine.
I can ask them to wait a little bit so they're starting right when I leave, and they'll get you an extra hour.
That would be nice. It is funny to think, oh, I'll put it in an int. That's a smaller number. No, it's Godot. It's all the same. Doesn't matter. How's it going, Obsidian? All right. So this is all cleaned up. Now we need to now we need to set it up so that we're sending this all the right way again. So chilling until the next Godot Wild Jam is this Thursday. Nice. Input magnitude. Okay. Almost there. Surprisingly, not a lot to do. But we do need to add this to clients. Connected client. This is going to be all busted too. And this is a lot of DRY, right? So we could clean this up even more. But a lot of this is actually going to change too. So there's no reason why I'm touching it. I'm not touching it yet. Input packet. Dude, these backyardigans. I almost want to just shoot the person who created that show. I'm kidding. I'm sure they're a great person. But dear God, that fucking song and the things. Okay, I have a feeling things are still going to be busted here. All right, so now we have magnitude. Magnitude is not a float, it's an integer. Int. Okay, so now we need to change. We need to turn magnitude into something else. And it's a hard number, so match magnitude. This becomes a float. We're not going to call it magnitude on the ingress. We'll call it mag. Match mag. And basically, it can be 0. It can be 1. It can be 2. Or it can be 3. So then, once again, magic numbers. What are we mad about right now? Do I not indent? No. That was weird. Okay, so now we can pick some numbers here. I mean, the magnitude for 3 is 1. And then so on. So we could do like, I don't know, this, and then 2 could be 5. Okay. Or how about a little bit like 7, 2.5 here, and then 7, like 6. Nah, let's see what this is like. Okay, so then magnitude's there. Then we multiply it by magnitude here. Okay. Get rid of speed. Okay. That's looking good. Backyardigans or the Baby Shark song? Which is worse? For me, it's Backyardigans because that's the one that's on repeat, you know? I'm glad they don't know that it's a TV show. They found the podcast somehow on our devices. And they freaking love it. Makes me want to. Rah! Oh, dude, it's some terrifying. They look like these terrifying creatures. I don't understand it. It's like Barney times 4. It's like if Teletubbies and Barney combined together. I'll be right back. All right. Did we get it right? You guys saw that, right? I hit the run button and then it did something like it was going to run and then nothing happened. Oh. Ah, shit. Now it's going to. 38 on what? Client. Oh, we're not sized. Cricket, you know what your problem is? You. There we go. Okay. We're looking good. Now let's try and run it on server connection. Oh. Oh, we're not decoding right. Okay, so let's fix the decode. Almost got it, boys. So now we have a reliable way to do this, and now we can do the same thing for the camera. That's what we're trying to get to here. Nathir got me. Got him. Invalid assignment of index 0. Oh, you know what? We're not we didn't size this. Line 46. We don't use speed anymore. It's magnitude, buddy. Okay. Look at that. Okay, so we definitely have that jitter that I'm talking about. And I think that's because our inputs, again, there's an off by 1. I'm confident it's an off by 1, but I haven't had time to fix it just yet. And look at that. We're snapping back to the direction we were. That has something to do with rotation. I got to figure that out. So let's take a look at that. Okay, Enos here. Okay, so that was the magic trick of 1 byte for analog direction and velocity. The lag is the input buffer. That's intentional. That's so that everything's smooth when we when we simulate the inputs, it's all correct. So we buffer the 20 frames of inputs, and then we start to play them back on the server side. So that's to be expected. It won't be noticeable. Like as a client, you don't feel any lag whatsoever. And then the simulation goes out to everybody. It shouldn't be, unless you're sitting with somebody side by side, you won't notice that there's a problem. Poseidon, what's up? I'm saying, oh, you're saying hi to Nathir. Never mind, Poseidon. You've been here the whole time. It's really throwing me off how you keep switching back and forth accounts. Just working. All right. Let's see GG. And we're going to... So what did we do here? Sending 64 degrees of directional and 4, it's really 3, but 4 magnitude, 4 degrees. I don't think degree is the correct term for magnitude, but 4 degrees of magnitude from 1 byte. Input analog input now makes okay. Cool. No, I don't think so. I don't think it's awkward. I mean, you got to be careful too, right? You don't want to call it like I'm trying to think of an example. Like you wouldn't want to call it you know, Medusa T. Dustin is at work or something, right? And it's like, wait a minute. So we have done all of this. And now the reason we did this is to figure out how to do it so that now we can do the same thing with the controller input for camera orientation. So I think this is going to be slightly different though, because we're not going to think of it as a magnitude thing. The difference that I'm going to do here is I'm going to split the axes up for camera, because the input could be coming from a thumbstick or it could be coming from a mouse. And we're going to take the axes and we're going to do basically the same idea, but instead it's going to be 120 how would we split it up evenly amongst, I guess it would only be 32 then, huh? 4 gets us 1, 2, 16? I always get confused. 2, 4, 8, 16. 2, 4, 8, 16. Oof. We might have to use 2 bytes for the camera. Ugh. No. We don't need to. No, because we have to translate it over to an integer. Jesus. Criminate. It's so that it has a better chance of reaching the endpoint. We're sending them unreliably unordered. So, like if we did just the raw floats, it would be 8 bytes just for that. We're able to send the last 20 inputs of any time frame. The last 20 inputs from any client is a total right now of 48 bytes. Every input, every series of inputs is only the way I'm doing it is it's just the raw. This is the byte. These sets. This part of this byte means this. This part of this byte means that. I haven't done anything like that. Wouldn't that be part of the packet, a hash code? I mean, I've never done that. So that's something that Zed had mentioned as well. But the bytes are sent compressed anyways. To a hash code to test whether the full set of inputs were received or sent. I'm not quite sure I follow. So you lose that precision in lieu of verifying complete data transmission? Verifying. What do you mean by verifying? Right. Right. Okay. Full impact. So by calculating the hash. Hash given by the server. I'm still not following. If the hash doesn't match. Why am I checking if the data is right or wrong though? I don't, if so, okay, I'm kind of doing what you're talking about already. The reason why it's 48 bytes and not 40 to send 2 bytes for 20 inputs is because I have a 64-bit integer that counts up for every single input sent. So I am saying what the head of the inputs that are being sent is. So long as I get one of the packets from the last 28 that have been sent, I can reconstruct the input order exactly as it was. That's why there's that little bit of delay that you're seeing there. So that's how I'm doing that. And that's why I'm doing UDP is because it's because of the speed. I may be able to drop that down even lower. I don't know. I haven't tried. I haven't actually gotten this out on the internet to see what it looks like. And then all I do is if the last integer, if the last input number is that I got, because they come in out of order, if it's lower than the last one I processed, I just drop it and I don't even do anything with it. Does that make sense? But if it's greater than a certain size. Yeah, but that's coming from like Godot is if that's happening, Godot's reconstructing it for me. I don't even see that part of it. As far as like whether or not the entire thing came together or not on the other end. I just see it as the complete, like it either made it or it didn't. Godot figures that out for me. I'm presuming the engine's doing that. I'm not worrying. I don't know what I'm not. I think you're thinking I'm worrying about something else. I'm not worrying about that. It either gets there or it doesn't. But the size matters. So I'm trying to just get them to be tiny so they can make it across the internet, because there's just different reasons why they wouldn't if they were larger. For UDP, as I understand it, as I've been told by a lot of people in chat. And by all the GDC talks that I've seen about this. Like you want to keep that small. Yeah, it is. I mean, I've thought a lot about this. I've read a bunch of stuff about it. I'm doing this based on a lot of things that I've read, and there's been a few people in here I'm pretty confident have done this before, that sort of guided me towards this, and I was resistant of it, and then I started looking into it and understanding it more. And it seems to work. There's like one little bug that I have right now that I need to get worked out, but it's actually really astonishing how well this works. Because I was getting a little worried. It took me about 3 months to kind of get it all figured out. Or not 3 months. It took me about a month to get it all figured out, about 30 days. And I was getting worried near the end of it. No, I don't. No, not at all. No, it really isn't. It really isn't. Because, I mean, you're seeing me, the result of it is right now. Every single input is processed using that, and it's like unnoticeable. This is using it right now, even when I'm playing single player. And it's like, you can't even tell. So, I mean, you can bear it, like if I kind of move it, like you can kind of see it right there. But when I was playing, I'm playing a game that does network code as well. And I could see this exact behavior, and I was wondering why it was that way. And now that I've figured this out, I realized, oh, that's one of the reasons why. Because it's not like the movement was never perfectly smooth with the analog input, and I was like, I wonder why that is. And then it came to me about how to do this, and I was like, oh shit, I get it. But yeah, I have 3 varying speeds of movement. Yeah, I mean it's all conceits, right? It's game design. You're making certain conceits for different reasons, and those are my reasons. Um, but I can now doing it this way, I have far more accuracy than what I had before, and we can now I can send like I was saying, 1, 2, 3, 4, 5, 6, 7, 8 more. I can send 8 more inputs with the exact same packet size that I have still. So this slow, medium, fast, we're not even using this anymore. We can get rid of that. And then camera rotate, camera clockwise. We're not doing any of this. Although we might use this concept here, because this was another thing I was noticing about the camera behavior. I won't talk about it directly just yet. Um, hmm. So I think for the camera though, we might need to do if the game didn't need the camera angle to calculate the input direction to use, I might not care about this, but it does. So trying to think about this. All right, Obsidian, have a good one. Yeah, Zaflins, thank you. But yeah, I think it's going to be, I think as far as like perceptibility, it's going to be non-existent. Like, unless I told you about it, most people I do not believe are going to even notice that their directional input has been reduced by those degrees. At least that's my feeling on it. I could be wrong. Hmm. I simultaneously nickname jittery. I'm definitely doing this against like what I think most people would I mean, this sounds like the way that you do it when you want to make it so lag doesn't seem apparent. Like, so for instance, we're sending server ticks, that is updates of the state of the world. This client down here is getting the updates from my other player here, the world state, at only a quarter of a second. Every quarter of a second, it's getting those updates. So we're doing that on purpose, again, to control the data that we're sending, the size of the data, how much of it, how often we're sending it to our clients and everything, so that it has a better chance of reaching its destination fast. So we're introducing lag in order to make it easier to have less of it, right? And then also, now, do we even need to send a buffer? I don't know yet. We might not need to do it that way, but I feel better doing it that way. And I have proven that it works by creating lost packets, by testing that and creating lost packets and everything. And it all still just works. So, and then, yeah, I mean, we'll see when it's out in the field. If it's working right, what you guys are seeing here is exactly what it'll be like when you're playing it with other people. And we're going to have some QoS things in the place, but what you see is what you get. It should look that's, I mean, because look at this. This is the ticks, and we can smooth the player movement. We're not doing it yet, or the player rotation. And I've talked about why we need to think about that in a different way. But this is, I mean, it's looking really good. And once we get the player rotation smooth, I think even that's the only reason why you're even seeing snapping right now, or that there appears to be snapping. And so once we smooth that out, it's going to be just like, it's not even going to look like it's only updating every quarter of a second. And we're going to, so far, in order to make the world exist and do everything, we're really only needing to send something like X number of players produces a certain number of bytes. We don't have to send the player bytes. So like on the sim packet, we don't have to send the player inputs or anything to reproduce what it's doing. Yeah. Yeah, I mean, it's interesting. It's an interesting problem set. It massages the brain, but most of all, I'm trying to make a game that plays well networked wise, and using Godot's turnkey of the multiplayer sync for me has shown a very choppy movement of like, you're just sort of like appearing around. If you've got lag, it's just like people are just popping in and around and everything like that, on top of the fact that the client is telling the server where its position is, which is not how you want to do it. And so by sending inputs, we send far less data for every player, which means we can send it far more often, which means that we can get way more updates, and we can deduce things way more easily that way too. So it's my understanding that a lot of games, this is how they do it with rollback. Are you assigning the corrected position immediately? So what I do is the client keeps track of its, when it did input, 12, it was at position, A. When it did input 13, it was at position B, and so on. And we keep a histogram of that, or not a histogram, but like a history of that up to a certain point, and we drop it. And if we and then we get the server simulation packet comes in and tells the client what everything is going on, and it tells the client, the last process of yours that I simulated was, input number 45, and I had you at position A. And the client goes and looks at its input 45 because it's constantly rolling through that buffer. And it looks at that input 45 and it says, what position did I have? And if the two match up, it goes, okay, we're cool. Everything seems to be fine. And the state comes from the server tick. So any sort of like doling out of certain points and stuff like that, unless we can trust the client to handle certain things, or we don't care, the truth of everything ultimately comes down from the server. If that makes sense. So it seems to be working. And I was trying to do the math off the top of my head. Let me print it out. We're lerping it. That's how I'm smoothing it. So we're not using input prediction. I'm not doing that. We're not using input prediction for the clients. I found that it's too much. It's really not, because of our tick rate, it's not helpful. We're not a fighting game with a low tick rate, so input prediction isn't helpful. At least I've found that to be the case. So what I am doing is, we're introducing whatever our server tick time is now an additional point of latency or a lag. And we are lerping the player position from its point to its next point. And eventually I think I'm going to include a curve data that will allow it to lerp more like the history of the movement between server ticks. Does that make sense? Because I think we can do that with only a few, like maybe we could create a curve with a couple of integers. And then we can have it be much more natural, matching what the other players were actually doing. But I think using the built-in Godot tools is fine for a lot of things. But I think that the conceit with it is okay. It makes it so you don't think about this stuff, which is good and bad. But I think the major conceit has to be acknowledged, which is that for some people, the experience will just be poor. And there's not much you can do about that using the built-in way that it's doing it. And that's not to say that, anybody could have a really shitty internet connection or whatever. And so that's still a reality. I haven't. I've seen that. But the thing about that is, what I worry about with that is that I'm using someone else's interpretation of how this should be done. So in our case, what they're calling prediction, we do that. The prediction is that the client is always saying what it's doing and it's immediately executing it. So from that sense, we are doing prediction. And then we're constantly reconciling with the server and rolling back if something's wrong. We roll back to the position we were supposed to be at according to the server, and we replay the inputs from that index forward. But we're not, when we do that, we're not lerping that. That's why we're getting that stuttering, because I think I have an off by 1 error. Anyways, so the simulation size, let's just see. I'm curious about, I haven't even checked how big it is. It's 51 divided by 8, and that's how many bytes it is. So 8, close to 8 bytes for the sim update, for the server update. Now the individual client updates right now, see, we're still putting in input dir. We actually don't need to do this anymore. We do need to put rotation, so we can make this smaller. Let's get rid of it. How's it going, Slindy? Yeah, so now our packet size is 32 bits, just about. So that puts us at what? That's 4 bytes. So on a per client basis, the amount of data we have to send is what is this? Oh, that's our ID. So 8 16 24 and 1. So that means that, so 25 bytes per client for the SimTick update for now. And that might be all that we need, really. And the rest of it is world state stuff. And we're trying to keep ourselves under 4,000 total. So we got lots of room to work with. Well, I think my brain is fried.
Yeah, I'm gonna go.
Okay.
They just started their switch.
Okay, he handled it well. I heard the tears.
Yeah, we played some Battleship, but we didn't finish.
Okay.
Okay, if you want to finish it with them, you can play mine.
Okay.
Okay, I love you.
Love you too.
So they
Drive
have-
safe.
They've probably done about 10 minutes.
Okay. I'll set a timer. So now I'm wrapping my brain around the directional stuff here. Anyways, enough explaining. I'm proud of this. And I don't like the feeling to be made not proud of this work. Because why not? I have the whys. I feel good about it. And the proof is in the pudding. I think once we get this out to play test with people. Now on the 13th, I should get my paycheck from Medusa Tea. My Twitch money will come rolling in, and that's when we're going to be able to pay for the Steam page. So we'll pay for the Steam page. Then we did the LLC last month, and then we'll be able to do the Steam page this month. And once we have the Steam page going, we'll be able to give out some playtest keys, and we'll finally be able to start testing this with other people. But before we can even do that, though, we do need the Steam page going so we can start getting access to the Steam API. Yeah, the Steam API. Jacob's 5 gifted subs from Jacob. Nice. The Steam page fun.
Shut up and take my money.
Thank you, Jacob. I really appreciate that. So we're gonna do the Steam page. Now Jacob's contributing to the Steam page. No, not you, Rig. No. I'm not saying you at all. No. It's just when I'm made to be defensive of what I'm doing, and no conceits can be made from what it is I'm trying to explain. It can get a little frustrating. So I think we all understand. No, what you're saying is, hey, somebody may have already done this for you in Godot, and that's not bad at all. So yeah, so I mean, I have my reasons. And yeah, UDP packet size does matter. I mean, I've literally, like, Rig, you've said as much. You've given me the white paper, right? Or am I thinking of somebody else? I'm trying to remember. Maybe it wasn't you, Rig. I might be thinking of no, I'm thinking of Gina. Gina had brought it up. Gina had brought up a white paper that explained why there was really like an optimal size or minimum. Like you really can't go over a certain amount with UDP because some routers are just going to drop it because of how packets pass through them. Yeah, it's a small number. And you do want to use UDP because you want those ticks to be as fast as possible. So you're trading reliability for speed. Right. So you're trading reliability for speed, and then you're using everything in your powers to mask all of that. Hang on a second, guys. I think I might have to stop the stream. My kids are yelling at each other. They can't be left alone for 2 seconds before they start screaming at each other. Get ready for the ride of your life. So what I was saying, correctness. Yeah. So we just drop whatever we have in a header for the SimTick. We have a incrementing number, and we just drop. No, I'm sorry, Rig. I was just referring to, if I'm trying to explain something and everything, and it's like, well, it's your choice and everything. That's where I feel a little bit like, well, that's kind of reductive, and it makes it seem like the way, like I have no validity in what it is I'm doing, and that's what I'm referring to, where it's just like I'm just sort of wrong. It's a little frustrating because I feel like I've done a lot of research into this, and I thought a lot about it, and I'm finally getting to see evidence of its success.
Sit down and have fun. Just sit down and have fun, damn it.
And so, having not witnessed any of that, and then, to kind of, I don't know, it's just a little kind of bothers me. I'll just be honest. Carl Devil, thanks for the follow. Also, to be pedantic, UDP doesn't use packets but datagrams. Right. So that's the one thing I don't understand is the whole channel concept of UDP, Slindy. It really makes my head scratch. No, I didn't say you said that. I'm trying to be vague here, Rig. I'm trying not to. I'm not talking about you, Rig. I'm just trying to be general. But we seem to have some sort of train going on here. People are running a train on me, it sounds like. But no, it is what it is. I mean, everyone has their opinions and stuff, and I always appreciate it, and I appreciate being challenged and everything. I think that with netcode especially, to say there's one right way to do it, I think ignores the entire like that netcode is its own sort of massive set of conceits. Like I should just use TCP. Every packet would be guaranteed, and but then it's like, well, but now you're choosing a whole nother host of problems if you go that route, and you're choosing the game to play a very specific way, and you're choosing lag now becomes a different thing, and because lag is inescapable with network games. Minecraft uses TCP for everything. It makes sense for something like that. Are you sure though? I think, wouldn't it use, doesn't it? A 100% sure? But it doesn't, it says it here, it uses both TCP and UDP for networking. Java relies heavily on TCP, while Bedrock uses UDP. Yeah. No, and see, that's a conceit that makes sense for Minecraft because it's so driven on who broke the block. Like, you need to know, like, and if you think about it, the design of it, it like makes complete sense that would be this case. I would imagine using TCP for like block breaking and the simulation stuff for some of that, but then using UDP for player position. But I guess they're not doing that. But I mean, I can see TCP. It's like, you could say, oh, I'm trying to break this block. The client says it's facing this block. It's like, okay. And it says, let me know when you stop trying to break the block. And then if the client, if you never get that message, then you go, okay, the block is broken. or the client says I think, you know, so it's usually just fine. Yeah. Hopefully Gina shows up again so I can show him what I've done so far. Okay, so the camera stuff. So how many do we think we need? We're fine with 64 on the I think we have to go the full thing, the full range for the axes of the camera. So we're going to split let's start working that out. But yeah, I mean, with Minecraft, you're having to send, you know, you've got entire chunks that you have to send, right? And so you can't, you got to use something like TCP to get that across reliably. And then you're dealing with so many authority related things where, yeah, we could do that. We could do that. I don't have much time. And for some reason, my, let me log into it here. I gotta, yeah, still they could have done the movement. Yeah. I mean, that would have been nice. It's almost barely noticeable, but I can only compare it to Bedrock. When I'm playing multiplayer, I'm generally not on, I'm sorry for your loss. Yeah, Bedrock's a real Trojan horse. They wanted to take things out of Minecraft and they found a way. All right, let's do this. No, it's fine. Hopefully the controller will work. Not Medusa. Now they messed it up. You can't even put on your own skin anymore. Dude, you should see the stuff they sell in the store. It's trash. Oh, shit. Sorry. Look at all these ads. What is this junk? Ooh, some lag. Chicken. This is lame. Oh! Oh! Oh God! Oh! Sweet Jesus! Oh my God! Damn, it's Rig versus Ghost. Rig trying to keep a well open. Oh God, this might be it for Rig. Oh, that's game. All right, Slindy's in. Cricket's private room. Join now. Callers are standing, operators are standing by. Somebody's about to get nuked. I'm sorry about that. I thought I was doing so good. I thought I was doing so good, and no. Slendy drowning in the blocks. It's down to Ghost, Rig, and not Medusa. Ghost having the cleanest board. Rig hanging in there. Medusa, a little bit of housekeeping necessary in order to stay in the game. Oh, but the blocks keep coming for Medusa. The blocks keep coming and they don't stop coming. Doo-ba-doo-boo-ba-doo-boo. Ba-da-ba-da-boo-boo-boo-boo-boo-doo. Oh my god. Medusa hanging on, drowning. Well, so the other thing that I'll say is, even if I'm saying like, oh, you know, that frustrates me or whatever, it's not like I'm like I'm holding on to anything or whatever. You know, it's just, I'm just saying like, it's a little, like to have worked on this for so long, and then it's like, when that happens, when it's like, why are you doing any of what you're doing? That's where I'm like, okay, I get a little frustrated. But, you know, everyone's, and there's always better ways, and I don't know what they are. I'm not saying I'm a genius or anything. It's just, it's a little... And thankfully there's people like that in my chat. I actually tend to, when I see somebody and I kind of disagree with what they're doing, I generally don't say anything. I'm just like, oh, you know, we'll see what it says. I mean, hell, I don't think, you know, ultimately it's the output of a game. I mean, you could look at Undertale or something like that and be like, oh, they're bad coder. And it's like, well, yeah, but they still made Undertale, so I don't know what to tell you. So who am I to judge, really? But I do appreciate it. That's the thing is, you know, it is what it is, and it's just, it's good to be challenged, I think. But it's challenging. Otherwise, why would you not, you wouldn't call it anything else. Damn, Ghost has been holding on this entire time. Ah! Rig just subtly sending the little punches here and there. Oops. What's going on here? Alright, let's do it. One more time. Okay, I'll go. Bye-bye. What is this about? Damn. Ghost hanging in there again. Should we do one more, or is that it? Should we call it? I think almost all of us got a victory in. I think we should call it. We all got a victory. We're all tied. One more? All right, tiebreaker. This is it. This is the tiebreaker. Shit! 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 It's Ghost and Rig. Oh, Ghost lined up for the almighty Tetris. Oh, a slight error on Ghost part. Oh, crap. Ghost now trapped. The well is broken. Ghost having to clear it out. Oh my god. Come on, Ghost. Rig is board is clean as a whistle. Ghost, hang in there. Oh my god, Ghost keeps having to put pieces where pieces shouldn't be because the fates of the gods of Tetris are worked against him. Come on, Ghost. Rig just holding on to a clean board, sending slight jabs after slight jabs. Ghost almost cleared out the board. Almost has the room for the Tetris. Almost, if he can hold on. Oh, Rig. Or Ghost is freaking out. Ghost is losing it. I can feel the pressure. Ghost! Oh my god, Ghost somehow still hanging on. Making decisions in rapid succession. Oh my god, Ghost still hanging in there. Oh my god, Ghost! Ghost! Oh, sweet Jesus, Ghost stopping him. Oh my god, he's got room for the Tetris. Ah, it's over! Simman, how's it going? It's going good. All you needed was that Tetris block and the tables would have turned. All right. God, it all went back to that right when you accidentally closed the hole. The well. When you blocked the well off, it was like, oh no! Okay, so I think we're gonna make a concession of 2 additional bytes for camera data because we have to have it. So we're gonna say that we're gonna say that much is true. Okay, well, let's reassess the facing buttons input map. What do they call them in Godot land? So right action, left action. Okay, we'll use that convention so that we share something with Godot. So what we're calling action that's left action and right action. Now, unfortunately, this only makes sense for a controller, and even though we're going to end up mapping this to so our lingo here is going to be tied around the controller verbiage for this stuff, but it's really not that. Okay, and then slow is now going to be, so how is it referred to in can we close this out? Dude, why is Godot so slow right now? Is that any good, Ghost? I keep seeing clips of it. It looks really interesting. Have a good one. So far, it's peak. All right, Ghost. Have a good night. Top action. We can get some top action and some bottom action. Oh boy. Oh my. Okay, so bottom action. So top action, bottom action. These are all the facing the controller buttons. So these are the facing controller buttons. And then what do they call the shoulders? And I don't think we're going to use the analog inputs, the analog triggers. Power bottom action. Hot power bottom action. Too hot for TV. Left shoulder. Left trigger. Right shoulder. Right trigger. Okay. So we're not going to pass the analog information from the triggers. I don't think we're going to need that for anything what we're doing. So left trigger or left shoulder, left trigger. Now the trigger buttons create a little bit of a logic problem. They're kind of annoying. Because depressing and pressing is a little bit of a, it's a little depressing. That's kind of the problem. Okay, so 1 byte now is the analog input. 1 byte is now all of the buttons, all of the front-facing buttons on the controller and the shoulder buttons. We're left with a few. The D-pad is 4 bytes. I'm sorry, 4 bits. Then we have depressing the thumbsticks down if we want those. So that's another 2. So that's 6 bits. And then start and select, I guess, can be 8 total there. Now, the real question, though, with a lot of this is, which do we actually need to send to the server and which are happening local to the clients? And I don't have an answer for that, and that's going to come later in the game design part of this. We may find that as we are designing the game that we really only need 3 or 4 inputs that we actually send to the server, and the other ones do things, but they're local to the client, like settings or menu navigation or like switching gear and stuff like that. Although even with something along those lines, those are questions I'm not 100% sure on, but so we may find that we can, for instance, the D-pad, I don't know. It's unclear if we're going to need all of it. Like we may find that we only need 4, which means we could reduce, we could take, we're at 2 bytes. We may say we want to be able to spend some of them on the camera. But I think having 1 byte for all of our possible inputs beyond the left stick is probably useful. And then, so now we're looking at a total of 4 bytes for every input stream, because we're going to be sending the camera information across the line. So let's start working on that. Now, I'm wondering if we can put all the axes. Can you do something like, come on, Godot. Let me click in here. What's happening? Can I click here? I can. Godot. Bro. There it is. This was in front. So can we P cam axis X, for instance. Can we do this and then we say that we're collecting 2 inputs here? Up and down. And what would that look like when we get that data? And then, and that's actually the y-axis, I just realized. Because I'm a big dummy. Pcam axis Y. P cam axis X. I do want to look at Rig. I do want to look at the NetFox thing, but dear God, I got so much work put into this. I guess I should be careful of not falling into the sunken cost fallacy, but yeah. I just know their source is going to be all API-ified and it's going to be like 7 million. Well, let's see. Where do I go to get to the source? Release. Let's take a look. Yeah, it's all over the... So they're only sending... Oh, see, they have an input redundancy. I mean, this is what I'm doing. So yeah, so this is okay. So that's what they call it. Redundancy is a good word for that. Bunch of signals. I don't use any signals. I dislike signals, friends. One of the issues with signals in Godot is that they are not asynchronous and they will fire on everything that is listening for them immediately. And so you can slam your process step, not even your process step, but you can slam the game if you're constantly setting things up to, I'm going to just blast this out to a bunch of dudes all at once. So because of that, doing something like, but it depends on what you're doing. It depends on what you're doing. But also, I just don't like, I already dislike mystery meat or like choose your own adventure code, as I call it, where you're constantly having to follow this function code next to this, even though what's frustrating about what I'm doing now with the networking stuff is it ends up looking that way because I do have to split things out so much. During the idle stage of a frame, I think they're immediate if I'm not mistaken, but I don't use them save for when I need to connect to them because of Godot's API. But I never create my own signals. And I'm rarely relying, I try to avoid relying on the signals. It's one of the reasons why eventually I want to be able to send my own packets. Or to actually control the sending and receiving of the packets too. Which is something we'll get going at some point. All right, looks like my kids are done. Jump is going to be bottom. Bottom action. And this is top action. Or it was X, so this would be left action. And this is top action. So we're going to have to start renaming a bunch of stuff. So over the next 2 nights, we'll be working on the camera stuff. I thought I would have something more going for it by now, but we did a lot of really good stuff. A lot of really good stuff here. And we have a much better solution for analog inputs. Calder for flag, yeah. I just find that emits and signals make it really hard to track responsibilities, like what is calling what becomes real loose. And the other problem with signals is who is responsible for connecting the signals, and certain times you have to remember to disconnect signals, and just a lot of stuff that I just don't want to have to worry about, really. So yeah. Okay, so I've got another refactor in front of me. So we've got I think I'm going to try to deal with 2 things over the next 2 nights. Tomorrow night and the next night. We're going to try if I can stream tomorrow night. It's very hard for me to stream on dance nights. I'll be honest. I'm so tired at the end of a dance night. I'm exhausted. Oh, I don't know. I don't use them anymore, so I don't know if it's gotten better or something. But I probably wouldn't use them anyways. Again, it's just that I don't tend to structure things that way. So I find if I need to have something happen, I just call a function. And if I need to use a signal, for me, it's a sign that something is wrong with the way I have things structured. That I'm having to suddenly bypass what is things that we've instantiated and referencing and calling a function on it, to suddenly I'm just like, I don't know. It's something about the way my brain thinks about this where I just kind of avoid it. It's the same for singletons. Yeah, I don't poo-poo singletons as much as I think a lot of people do, but, or global scope broadly. For the games that I'm making, I tend to have a very static tree structure, and therefore I know where everything is. And so I'm just talking to stuff that way. So, and yeah, I mean, the other thing too is you could easily just create a static function if you can manage it. Right. Yeah, that's what I say. I'm not writing it off completely either. I wouldn't do that for sure, because like there are times, like for instance, I generally hate inheritance, and here with the packet idea, I am using that because I knew eventually there'd be like conceptually things that I'd want to repeat across the different types of packets that I build. Multiple inheritance, right? And that's the funny thing about object-oriented programming is the first thing you learn in object-oriented programming is the first thing you learn in object-oriented programming is, oh, it's really cool because you can inherit, you can create this thing, and then it takes its attributes, and then you can create the sub thing, and so on and so forth. Also, never do that. It's bad. It's like, oh, wasn't that the whole point of it? But the very original thing for it is like, yeah, don't do that. It's bad. Which I think is really funny. So the way that I'm using inheritance right now, because I have it in one thing in my project, is the input packet. It's just a way of guaranteeing that we have different behavior. I use it like I have two things with different behaviors. I'm not even using, like, I only use it for I mean, I could show you. I only use it for, I know that that a packet will always have a value and a size. And now we just did the U2 and U6 thing. And that's it. So I just like, it's to make a guarantee of like, this is always going to have these things, but never, I'm not using it for like, I'm going to override a function and, you know, like all that kind of stuff. Interfaces. Yeah. I mean, that's why I wish I'm using it more like I would use a struct. If we had structs, I would probably have done something like that instead. But it is more a promise to myself about, when you're doing this, think of these things. But even that, I think, is kind of going away for what I'm doing as I started working through it. But yeah, I don't know. I tend to, everything I write tends to be very linear and flat. Usually this project, it's all out the window though, because again, it's like the networking stuff is weird. But I will say that as much as I can, that one of the reasons why I like collecting the inputs, this is another thing that I didn't get to talk about earlier when Obsidian was asking me why am I doing it this way. Well, it was more about why am I compressing the data, but one of the reasons why I'm liking collecting the inputs and everything is that lol, I once gave this answer at an interview. They laughed and said, never expect contracts to be enforced via interfaces. Huh. It was a bake. They were assholes. You were using your Cobalt programmer, right? So have you done like the bank I worked for used an AS400. I think they had Cobalt in the back end. Pascal. Okay. Okay. Yeah, I mean, that's kind of the whole point. Like the reason why I don't like it from a coding perspective is that again, it's that removal and putting it somewhere else where I don't see it. If the IDE showed the injections or whatever you want to call it, like the agreements that I have from extending when I extend packet, if I could show what that's making me sort of inherit, I kind of would like that, but then again with Godot's API it would be a million things. Perhaps they meant contracts in a different sense than what I'm talking about. I'm not really good with these terms either. I'm just not. I guess I should be better about that. Like myself personally, I don't know all the comp sci names for everything. I just know like when I've done programming over time, there's certain things I really dislike. They were implying that bad actors committed. Well, but that's true of all the code that's written in, like if, right. But then at the same time, what is it? Yeah, I mean, you're going to want to do checks and balances in that kind of code anyways. But the implication there is that the source has been tampered with or that in some way something has gone wrong with that. Because yeah, you should expect anything like with accounting and stuff, any input you should be validating and any output you should be able to also do some checks on. That's a weird way to think about things because at that point it's already like, well, they can, if they have access to the running program, then it's like, because that's, to me, that's the implication, because you're talking about source. So what the hell are they talking about? Like they're talking about execution of it, which is a totally different thing. At least I would think that their implication is that it could be tampered with, but that's in that way, because why would it doesn't matter. I think you're yeah, at that point, if you can't even argue with that reasonably, then you're sort of like maybe not a good fit. And that's part of the interview process of any job. You find out, yeah, I don't want to work here. Just from that, you're like, I'm going to be working for this guy. Yeah, I'm good. Right. No, I totally agree. I was not happy. I did not take the job. Yeah. That's weird. Yeah, the expectation is you again, and that's the time when it's like, that's when you create setters and getters and all that shit that I hate. Is like in those worlds of banking and stuff. Like you need, the input comes in and you need to be like, okay, what's going on here? Where'd you come from? Like, who sent you? Like, do they have authority? Like, blah, 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 like all that shit. The worst is in a lot of places it's HR that we were dealing with this problem at the bank I worked at. HR was interviewing all of our technical hires, and we weren't allowed to interview them for a while, which was like the worst. It was unbelievably a horribly ineffective way of doing that. If a piano fell on the man, the world would be a. Oh my god! Two Bobs advocating murder. Complete skis. I find interviewing in the tech space is really difficult to answer questions to understand someone's thinking. Like, and I remember when I first started interviewing, I found myself wanting to ask questions that I heard asked in interviews. But the more I thought about those questions, I'm like, these are the questions people ask because they don't know what they should ask. Like, why do you want to work here is one of the dumbest fucking questions. But everyone seems to ask it. Because it's like, tell me why we're so great it's really more of a statement and not a question. Tell me why we're so great. MBA grads are the national enemy of software engineers. Why the fuck do you want to work here? Right. Yeah, you could throw it around on them and be like, well, I don't really know. This is a place that hires people and you're looking to hire somebody in this position. I sent my resume in and you are now interviewing me. So maybe we should throw the question around. Why do I want to work here? Like, that seems more of a question that I would ask you, not you ask me, because you work here. I don't. So tell me why would I want to work here? Obviously you're not going to get hired when you do that, but that's really like, that's a question for the person who's looking at the job. It's not the other way around. That implies that somehow you have an understanding of the inner workings of the company and like the day-to-day and everything like that, because that's ultimately what you're getting hired to do and be there for. So you can't legitimately answer that question. So I hate that fucking question though, because it's just like a really unthinking question. Why do you want to work here? Oh, you've seen TV too, huh? You've seen interviews on television as well, I see. What's your greatest weakness? Yeah. I don't know. Give pat answers to stock questions. My greatest weakness? Yeah. The fact that one day I will die. The greatest weakness I have is that I am not immortal. I ultimately will die like the rest of us. I'll keep that in mind as I interview prep. It's really hard. Like, it's more like, when I remember when I was hiring people for like a help desk situation, and it's like everyone that we hire, we're going to have to train because it's all in-house software and all of this stuff. None of whatever they think they know really matters for like a lot of the stuff. And so it's more like, okay, somebody calls and they're, I almost think putting someone through a fake call and just seeing how they handle it is probably, in that kind of job environment, is probably the best way to get an understanding of how they solve problems. Because there's just like a certain eloquence in like troubleshooting and understanding that people speak in ways that are not the way that you would in terms of like describing a software problem or whatever. But now I tried to, I don't know. It's all different. But yeah, I have no idea. Like, if I was hiring somebody for software, I have no idea how I'd even talk to them about it. I almost think that for me, the most important thing is like, can I work well with this person or not? And like, we're going to do the work anyways. Because I can't do it on merits of ability. Like, I'm not the person to determine that. I'm stuck trying to figure out how to deduce if my interviewer would be an actual developer or not. I just feel like you have a worse chance getting hired if someone non-technical was asking random unrelated questions. I think that's where the bullshitting works even better, Zaflins, though. But unfortunately, they're probably reduced to some scripted questions and they're looking for some sort of answer that there's a true or false that you have to like nail. But I have no idea, frankly. Dude, can you write the software we need? I still remember, I've mentioned this before, the first job I ever got that was that I got hired for programming in. I never worked in anyone else's code, ever. And I took it upon myself where I made an agreement with myself when I came in, first day, to get access to the code as quickly as possible to be able to look at it. And if I told myself, if I can't look at the code and understand what's going on, I'm just going to say, you hired the wrong guy. I'm sorry to waste your time. And then say, I quit. So that, cause to spare myself the embarrassment. And luckily when I looked at the code, I was like, oh yeah, I totally understand what's going on here. And also this is really shitty. This is some shitty code. I distinctly remember 3 for loops in a row, one after the other, that looped over the same amount of the same data. And I was like, oh wow, like this is like beginner, like super beginner rookie thing here. So I felt really good about it because I was like, I can clean this up. Anyways. All right, so we'll leave it at that. So what we're doing when I get back is I have all this nonsense that we have to do in order for, because we're doing multiple controller inputs. We send a certain CLI parameter to the game. It allows us to detect inputs from one controller or another so we can do the multiplayer testing with controllers. So we're going to have to add all these new button inputs in and get that all situated. And then the other thing that we're going to be working on for the next 2 nights is the camera stuff. Now that we have this clean way of doing it, that's what we'll be focused on. So like in the same block. Yeah, it was in the exact same. It was a for loop and it created some stuff that then, and this was PHP and it was creating some HTML, but it was a for loop and it generated some stuff. And then they for looped over the exact same thing that the other for loop did. And then they generated some other stuff. And then they for looped again over the exact same data that the first for loop did, and then generated some more stuff. So it's like, huh. So that could, yeah, it was way back in the day. But they basically iterated over the same, and what was, here's the other crazy thing about it is, I think there was also a database query that was happening that created the data that they then for looped on, and that was being repeated as well. So it was way worse than just a for loop. A lot of what I did initially when I came in was getting the queries down to a single, like they were hitting SQL, hitting SQL, hitting SQL, hitting SQL. And it's like, no, this is one page. Rationally, it has one set of data that it's going to be showing. We're going to, so the first thing I tried to do was get it to hit SQL once, because the server was just, when I came in, the server was already overloaded. So I was like, okay, let's get this down to a single query because that'll help me understand the data better and go from there. But that was a lot of like, it was, they always wanted everything, their turnaround, it was less than 24 hours. Everything was run to production immediately. Everything was straight to production. It was all real time, like straight to production. It was wild stuff. So I had to learn how to like, well, the nice thing about it was I was the only person responsible for it. So if anything went wrong, it was my fault. So oh man, yeah. If you hit SQL inside the for loop, yeah. Yeah. But eventually I got the whole thing to, because what I was responsible for was the data, they were hitting a database that was being used. The website was literally talking to data that was being used by the scientists. And so if the website was getting hit, the database for everybody in the whole system was slow. So the first thing that I had to, one of the first projects was getting it to replicate the data into SQL somewhere else. Because the actual data was through ODBC to something that wasn't SQL. So getting the database to replicate into a SQL database that the website could hit outside of the data. Yeah, dude, it was wild. But they wanted real-time replication of the science data to the website immediately. So I had to create tools to make that happen. And well, the guy that did it before me was my boss. So he was the one that made the code before I came in. Yeah, no, it was a nightmare. So so there was that, and then eventually I got it to the point where everything was cached. The data query was cached. So when the website would load it, essentially it was just loading the whole thing from a cache. And then anytime a data would change from the real data base, it would invalidate the website cache, and then it would pull in a new one on a page refresh. And then I automated that too, so everything was hitting cache data except for the shopping cart systems and all that. So eventually the website like got really fucking fast, but it took a while because it was daily tasks that had to be done every day. This needs to be done first. And I would try and sneak in some sort of optimization while I was doing that. So, but it was, yeah, I learned a lot. I had a lot of fun doing it. I miss some, for some reason I kind of miss some of that, but, I miss the money mostly. But yeah. Middle management. Yeah. Yeah. No, it was interesting. I was slowly moving over. If I had stayed with it, I would have been on Laravel eventually. I at the time I was using, I think I had moved over to, because I'd found a nice framework, because PHP kind of sucks. So you ultimately, especially for web stuff, it's like at the time it wasn't very good either. So finding a good framework they didn't really exist back then. But I started to move over. Yeah. I always try and get a project directly answering to the CEO or board. It's the only way to wrestle power away from your immediate bosses in the long term. Yeah. I just don't like the corporate thing. I don't like, I just don't like it. I hate that it's political. I hate that it's like, that's even a thing. That there has to be power plays, and I hate all that shit. I just want to get things done. Like, especially when you work at a job and they're paying you and it's like clear what the job is. And then it's everyone else who's working for the same company who works against you. It's like, what the fuck are we doing here, guys? Like, why are we doing this? This is why I need to quit, lol. Are you having some of the things I'm describing? I left Corpo not long ago after a directorship. Literally, screw that. That is your entire life being signed away. Yeah, every day. Yeah, dude, it sucks. It sucks, and it sucks too. I mean, it sucks that start my own business, never look back. Yeah. Yeah, man, it's a different kind of scary doing your own thing too. Well, I spent the last hour just talking, but that's fine. Let's go ahead and raid somebody. I got my kids I got to play with. I'm director of engineering, but the CEO decided he is a tech bro. Dude, at the bank I worked for, it was a nightmare. I had our IT department. Our IT department for 3 people working what was referred to as help desk. Okay. But it was really 2 people working help desk. 2 people working help desk, which is people call in, they have a problem, you fix their problem. That's it, right? And there's a ticketing system. Okay. 2 people to do that, a manager and then another manager. What in the fuck? And there was 1 admin. Now you could get rid of the 2 managers. There could be an admin and the 2 other guys. That's all we needed. But instead there was 2 managerial positions, 1 administrator, and then 2 people that actually did work. Oh God. And every time we wanted to make our jobs easier, they would say no. And then we'd have to prove it by like literally, that's when I started to learn how to program for real, was they would say no to some software or something that we wanted. And so I would just program it. It was just like, fuck this. We need this thing. I did that several decades ago at the Halifax Bank. I 100% hear you. Yeah, dude, it was awful. It was awful. Changing an icon on a desktop. Oh, dude, yeah, totally. Dude, one time they took away, they got rid of our admin privileges. They thought that was a good idea. So for like, it was almost a complete month of every time we needed an admin password, we had to grab one of them. Because they thought this was because they like didn't trust us or something. It was really weird. And they immediately, like, it took a long time. It was amazing how long it took them but ultimately what happens is what you'd expect, right? A CFO or somebody in the C-suite needs something and you're like, I can't help you. I don't have admin passwords and I have to get it from so-and-so's and they're both busy right now and they're not getting back to me. And then they get chewed out and then suddenly it changes again. But that was one of the more ridiculous things that they did, was completely remove admin privileges for us. And given the structure that we had, we didn't have like, it depends on the bank system and everything. But we were a mid-sized bank. We weren't really big or anything. We were $1 million bank. We weren't like huge, but it was wild how many dumb decisions were made. And anything to improve responsiveness, to like be better at our job or whatever, they just say no to. It was clear they wanted the friction because they wanted to have more people under them. That's really, I think, what was going on. Like, the harder the job is to do, the more people they can hire. All right, who are we going to raid? I wonder if there's anyone new doing some Godot stuff. I'm looking around at our count. We could do Conrad. Tapier's going. We never get to, let's raid Tapier. Never get to raid Tapier. Yeah, you too, Bob.
Make it wider and put the buttons vertical.
Zaffins, everyone. Jacob, thank you for the support, Jacob. Rig, Medusa, Everybody else that was here, thanks for all the new follows as well. Carl Devil, Tic Tac Whack, thanks for the follow. And then we got a raid. Zed raided us. Thanks for the raid, Zed. Unlock for buys. All right, Vex, have a good one. See you guys later. Bye-bye.